Space and Rocket Review. YouTube chats. Tell your friends. Space and Rocket Review. Space and Rocket Review. What's going on, everybody? Is the YouTube, we got a signal over on the YouTube side? Big space and rocket. Oh, okay. What's going on, everybody? How you doing? Whew. Hope everybody had a good weekend. It is Monday, April 21st, 2025. And this is the Space and Rocket Review. Let's see what's going on in the space world. There's actually a lot of Starship news. Yeah, a lot of hardware, different hardware being different hardware around all over the place at both launch sites. Yeah, pretty cool. Forgive me for what you are about to do. It has to be done. Whatever. Ad time. All right. Retrieved ad time. And I gave you warning. You are not forgiven, and I hope you burn in hell. Nat 20. All right. Enjoy your ads, I guess. That's great. Good. Great. Grand. Wonderful. Tell me when it's over. You know what? I don't want to talk to you guys anymore. I'm going to talk to YouTube chat. What's up, YouTube chat? How you doing? How you doing over there? Yeah, everything good over there? I don't want to talk to you no more. No, I'm over here. Looking forward to the show. All right. Good. Right. Yeah. Should be good. Turbo for the win. There you go. What did I do? You're guilty by association, Vin. Sorry. I was waiting. That's good. It's good. All right. How you doing? Don't know if you covered it last week. I can't do that. We're still in an ad break. Group punishment is a war crime. Oh, all right, fine. I'll just time you out then. That's a fair point. I don't know if you covered it last week, but the hot staging ring for 14-2 has a different unhold section on it and lines up with the sea level raptor. Using a sea level raptor to the hot staging rings to push down. What? All right, we can take a peek at that if you want. Pictures from the Lucy mission. I have that already. Have you seen the Gateway Moon timeline? No, I haven't. Please tell me about it. All right, I think we're good enough to go. All right, so NASA released the timeline for getting Gateway to the rectilinear halo orbit. Gateway is NASA's deep space research outpost that's orbiting the moon in what's called a rectilinear halo orbit, which is what this thing is right here. It's a polar style of orbit that uses lunar precession to always maintain constant line of sight with Earth. Pretty cool. So we got the timeline here. Let's read. 1. Gateway launch. Power and propulsion element, along with the habitation and logistics outposts, launched together on a Falcon Heavy launch vehicle. Okay. Okay, Falcon Heavy does its thing. Launch vehicle second stage burn. Second stage, okay, so it's a two burn to get to the gateway, or to get to a transfer orbit. Gateway separates from the second stage. Once spacecraft separation is confirmed, power and propulsion element deploys rollout solar arrays and undergoes 6 system checks for approximately 7 to 10 days. The power and propulsion element uses its electric propulsion to start lunar transit. The solar electric propulsion system will be the highest powered electric propulsion system ever flown, rated at 60 kilowatts. The first subphase, the spiral subphase, lasting approximately 300 days. Lasting approximately 300 days is where the apogee and perigee continues to be raised beyond Earth's protective magnetosphere and through the Van Allen belt. Scientific payloads will collect data on radiation as they travel through the belts. Alignment subphase. The next subphase is the alignment subphase. Okay. For approximately 60 days, the apogee continues to raise as Gateway approaches the moon. A plane change will be performed to align with the moon's orbit. Ballistic subphase. The final subphase is the ballistic subphase, lasting approximately 30 days. Ballistic subphase uses lunar gravity to perform an additional plane change and positions Gateway closer to the moon for lunar flybys. 10. Insertion into unique polar orbit. After completing a series of lunar flybys in long thrust arcs using the electric propulsion system, it will take 7 to 14 days to insert Gateway into a unique polar orbit known as the rectilinear halo orbit. Um, I think this is an expendable center core if I had to guess, Jack, yeah. It's a way to do this, I suppose. I kind of like, I don't like that it takes this long. I'm not going to lie to you. I'm not that big of a fan, but the spiral subphase is actually super cool. That's actually a super interesting part of the mission, you know, flying through the Van Allen belts. And what the plus side is that, you know, it's 60 kilowatt electric propulsion system. That's pretty powerful. I'd be very interested to see how those perform. Dude, when is this going to launch? I mean, it's going to launch, what, like 2026, 2027? It's not going to get there until 2028. Like, Starship's already going to be out at the moon. Like, how big do the panels need to be to make 60 kilowatts? Pretty big, Alexandru. Yeah, pretty big, dude. This has rollout solar arrays similar to the ones that are on the ISS. The IROS solar arrays. They're very similar. Will it? I mean, we're looking at baseline operability here, Cirrus, 2028, 2029. Yeah. Well, let me put it this way. If it's not, we got a big problem. And SLD too, same thing. Like, is this... I guess what I'm trying to get at is, like, Okay, let me rephrase this. I got a better way to put it. Better way to put it would be like, look, you have you have two lunar landers being fielded. You have SLD and you have HLS, right? Wouldn't it be a wiser decision to utilize that method of transportation to get stuff out there? I think that's a fair way to put it. Does that make sense? That this will be combined with Artemis 4 docking to it once it's there. Dude, by the point that I'm trying to make, guys, is that by the time this thing gets out there, it's supposed to be out there like right now. By the time this thing gets out there, we're gonna have way better ways to get stuff to the moon. I don't know. I don't mind Gateway, I really don't, but it would be a lot better if it was there right now. Like the whole point of putting it on Falcon Heavy was to do it quicker. Yeah, Gateway would have been really good if it's 2019 and you want to launch it in 2024. Yeah, that's really, then it's really good. But yet here we are, the the Halo module and the PPE are nowhere near finished. We're looking at another year of processing at the very least. Then subsequent integration, Falcon Heavy launch, and then another year after that. That's the point that I'm trying to get at. That is well into 2026 before this thing ever gets off the ground. We're already going to have a better way of getting there. Either coming in the form of HLS with Starship or SLD with Blue Origin. I just don't. I don't know. I'm not really like a big fan of this, you know? Like, this was a good idea in 2019 when we were going to put people back on the moon in 2024. That would be the time to have made this. In my opinion. Either way, this is a cool mission. I do appreciate it. The spiral subphase is pretty cool. Flying this thing through the Van Allen belts is a pretty awesome idea. Well, I look at it like that, though. It didn't happen. Neither has Starship or Blue Origin. Yeah, that's a fair point, George. I just think I read some stuff with a government accountability report a little while back about the management of this program. It's frankly atrocious. Yeah, it's terrible. The people doing the mass analysis on the habitation and logistics outpost forgot to incorporate the mass of the wire harness for the habitation and logistics outposts into their final mass calculations. Yeah. Oops. That actually, them not taking that into account actually is a major colossal screw up, because it put it so Falcon Heavy can't put it into as far of an orbit. It's actually too heavy for what it's trying to do, for being launched on Falcon Heavy. So they had to eliminate stuff from other places, as far as I know. Yeah, they miscalculated by about 1,500 pounds, which that doesn't sound like much in the name of like in space flight, but when this is your final destination, 1,500 pounds is a huge difference. Yeah, I think it was that singular point where I was just like, all right, get rid of this thing. I think personally it would be much better for Artemis 4 to take an EUS and make an EUS into Gateway. Actually, like, just put the habitation and logistics outpost on the front of an SLS EUS Block 1, which was kind of the original idea. And then just figure out a way to use the Orion SPS to stop that thing out there. But I think that would be a much better solution for testing out transfer vehicles, because that's what Gateway's supposed to be. But yeah, that's just my opinion. Because the EUS is ready and all. Yeah, I know. I'm not going to say that there's just not poor management of this program basically from the ground up, but there's poor management of this program from the ground up. At least it's progress. At least we got a good mission profile. It wasn't that, since they incorporated Maxer PPE in Halo, that threw it over. No, it was that. I read the report. We did a pretty detailed analysis on a Space News one time, dude. It was that. They absolutely forgot, and it made it too heavy. Also, Starship can't dock to it. The thrusters on Gateway are not powerful enough to be able to move the mass of HLS, so that's a whole nother can of worms that you're going to have to deal with. Do you think when it launches we could dock it with a tug and cut the transfer time? Yeah, I don't know, man. I don't know. I just think this is a really, really complicated mission architecture for what you're trying to do. This is a really, really roundabout way, quite actually, a roundabout way of achieving this task. Starship didn't exist at Gateway design. Turkey, I'm not sure what point you're trying to make. What so? It does now. Maybe you should have taken that into account before you selected Starship as your lander. Just putting it out there. Like, not trying to be mean. Like, the whole thing that I'm trying to emphasize here is that the management, there's just, this whole thing is a programmatic nightmare. It's a nightmare. Like, we are picking the absolute worst way to get back to the moon to try and get back to the moon. This way. It's good, I guess. This way, this would make a lot more sense if we were already doing like Apollo style stuff, but we're not. This is we literally have the most steps of going back to the moon. This is way more complicated than Apollo. Like, believe it or not, I know that sounds ridiculous. Can you get something from the production site to Massey's in an hour? Yes. Yeah, it's possible, David. Barely, but it's possible. Do you believe HLS is going to be built anytime soon? They need to stack the prototype. I have my doubts, Trey, but I think they were just not able to see the progress that SpaceX is working on it. It has a NASA docking adapter all over to Starship. The HLS variant, Turkey, yeah, of course. I feel like they're getting hung up on the sustainability part of it. Yeah, Sears, this is really... I like the mission. I really do. This is super cool. If it's 2022, and this mission is launching tomorrow, yeah, this is awesome. Great support system. This is really cool. I love it. This is awesome. But it's not. Why didn't they start with Apollo as a baseline and work out from there? Politics, Badger, is the answer to that question. Yeah. Politics. We were going to try, like, Constellation was basically supposed to be that. But we didn't want to do that. So, yeah. Allergies are starting to get me, dudes. But yeah, we had kind of a set plan on doing this with the Constellation program, but we decided we didn't want to do that anymore. Bless you. Thank you. But yeah, that's the mission profile for the Gateway. It's going to take about 400 days for it to get to its destination. So, I mean, I like this mission. I think this is a cool mission. It's a cool mission, once again, if it's 2022. And it's launching tomorrow, but it's not. 400 days to get to the moon. Is that a joke? Nope. Yeah, Oten, Destin, Smarter Every Day agrees with me. Like, and I say agrees with me. First of all, first and foremost, Destin is way smarter than I am. Like, way smarter than I am. But with that being said, I've been saying this exact thing for years now. Yeah, I don't like this. I don't really think this is a good idea. At this point in time, like, why would we do this? Why would you do this? You're going to have 1,000 better ways to get this thing out there by the time this thing gets out there. I've not heard about saving 30 billion in a while in here. Yeah, I've been trying to just keep that on the down low, Cyborg. Yeah, Viper. Yeah, I suppose at this point in time, it's probably not a good idea to cancel it because stuff has been made for it. But once again, this thing is going to get out there. It's going to park in its final orbit, right? It's going to park in rectilinear halo orbit, and we're already going to have 1,000 better ways to get it out there by then. Hey, Arsenal, how do you do, fellow kids? 94-month resub. Thank you. Do we get more speed when we run around Earth? Hexu, yeah. You have to just boost a little bit every time, because when you're closer to the surface, you're actually going faster. So if you're in an elliptical orbit, right? You know, you go up, Earth pulls you back. If you accelerate a little bit at your fastest point, your overall speed increases. You boost your orbit higher and higher and higher. And that's called the Oberth effect. Yeah, it's a super efficient way to get things to places. The problem is that it takes a long time. Utilizing Oberth effect like this with low energy is a huge low energy transfer, and it takes a year to get out there. Coming up on 8 years, that's right. Could they change it to a better thing when doing the original orbit? I mean, I don't know. At this point, I think Gateway's only happening because there are international partners for Artemis, for the Artemis Accords that are specifically contributing to it. Yeah. Okay, so in your opinion, what should they do with Gateway right now to make you happy? Oh, a fix. Yeah. Okay, give me a second. I'll explain. Because, dude, I don't just say this is a dumb idea. I don't believe in just shooting stuff down, right? I always want to, like, if you can't provide a solution to this problem, then you shouldn't point out the problem in the first place. So, I think our solution lies here. All right? So, take a look at this. I'm loading up a picture. Give me a moment. So, this thing, right here. This is the exploration upper stage, okay? The Block 1B version of SLS is going to use this. This is being manufactured right now. They are working on it. I don't know why they won't tell anybody that they're working on it, but they're working on it. Sorry, you're going to have to take my word for it. They are building this right now. They've gotten past confidence wells, and they've started making them. What I would do, if I was in charge, I would make more of those. Now, why? Okay, do you see this thing right here? So there's Orion, obviously, up at the top, right? You have Orion up at the top. You have your European Service Module. And then right here, you have a conic piece called the Orion Staging Adapter, or OSA for short. The OSA is connected to the top of this structure right here. That is called the Universal Staging Adapter, okay? And it's basically a payload bay for SLS. It's basically a payload bay, right? Now, the original plan for the Artemis program was to carry the power and propulsion element in here. Orion gets out there, or they get on a transfer. Orion plucks the power and propulsion element off, parks it in rectilinear halo orbit, and leaves it there. And then the next SLS mission will carry the habitation and logistics outpost. Orion plucks that thing off. And basically, when Orion's out around the moon, you use it to build the gateway out there. That plan was axed for whatever reason. And they decided to take the Halo and the PPE, attach them together, launch them on one Falcon Heavy, and then do that. Now, I don't think that way is okay. This way's all right. It would have been okay if, you actually built these. That would kind of help. It would help if you made more of those. That, to get this stuff out there, you kind of need rockets. It's kind of a requisite. Understand that's kind of important. You need those. Anyway, I digress. Not by much though. My solution, dude, at this point would be to take EUSs. So the EUS is already a power and propulsion element. This thing has station keeping thrusters on it, right? Take an EUS, modify its propulsion system down here to utilize that same 60 kilowatt propulsion system, right? Mount a thruster array down here, which you could do. Basically hotwire the power and propulsion element into the existing EUS, which already has power systems on it. Outfit this thing with the thrusters that the PPE has, and then inside of your universal staging adapter, put the Halo module. And then on top of this entire thing, if your mass becomes a problem, which I have a feeling that it would be if you tried to do this, right? Just put a nose cone up there. Put an Orion launch abort system up here. Put the abort system nose cone up there and then launch it with that. Nose cone jettisons just like it would with Orion. The launch abort system, nose cone will jettison. No Orion there, just nothing. Right? And then go from there. This thing gets out there in one shot. It gets out there in a week and not, a year. Now, I know there's some things with that mission that people are going to say, EJ, I don't know, man. How is the EUS going to circularize around the moon? Well, that's why I say a week and not 3 days. You'd have to opt for a lower energy transfer because this thing is going to take some time to circularize. A circularization and capture with the electric systems when you're moving the entire EUS could be a little bit troublesome. That could be hard to do. And by could be, I mean it would be, because the reality of the situation is that electric propulsion sucks. It's terrible. It's terrible because it's all solar powered. Electric propulsion could be scaled. It absolutely could be. If we didn't have it completely off of solar power. You tap electric propulsion into something like a nuclear reactor on orbit, you have something like Star Wars. But we won't do that. So that's kind of where this plan kind of breaks down a little bit. So the other solution would be to get your power and propulsion system out there with an EUS, which you're already sending, right? And then have Orion's SPS do a capture, right? And then have this thing do whatever this is around the moon. This like sub-phase capture around the moon. That's my solution. Now, why? Why would you do this? Why do this way? Isn't that a little complicated? Well, yeah, of course it is. But this puts the power and propulsion element on something you're already launching. You're already launching that. You're already putting that into space. And the whole purpose of Gateway is to test potential transfer vehicles to Mars, right? That was the whole idea. That was the whole point. Use Gateway as a facility for researching going to Mars. You are not getting to Mars with 60 kilowatt solar electric propulsion systems. You're not doing that. You're not doing that. Now, I know what people are going to say. Well, why? Why? That's the same. You're not doing that for the same reason that if you took a leaf blower and put it and strapped it to your back, you're not going to fly. It's just not enough kick. There ain't enough power there. I'm sorry, there's not. Like, it's just, that's physics, man. Like, you're not using that as a transfer vehicle. So, the whole point of the Artemis program is to practice, do stuff out at the moon to practice going to Mars. All right, so we're going to use Gateway to kind of test out prototype potential prototype things for something that's going to transfer us out to Mars. Yeah, where are those at? What are we doing there? I have a feeling that, maybe with Rook things will change, but I have a feeling that Gateway is probably going to spend a lot of time out there and it'll end up becoming like the ISS. The ISS was originally Space Station Freedom. That's what it was supposed to be. It was supposed to be just a stepping stone for the shuttle to use as basically a cargo hub on orbit so you could build transfer vehicles to get back out to the moon. That was the original point of Space Station Freedom. That was the idea. To go out to the moon. Part of the Strategic Defense Initiative from George Bush Sr. in 1989. That was the whole idea. Yeah, I don't think that worked. So I have a feeling that, like, what is this? There is no follow-on architecture from this. You learn the technologies, and that's all fine and dandy. But we've had the technologies to get to Mars for a long time. You might as well build the technologies to get to Mars that we have for a long time into a design that you can actually use as a transfer vehicle someday. Does that make sense, George? Sorry, I don't mean to get all like pissy about it, dude. Like, it's just what is Gateway going to do at this point? What could we learn from this that we're not going to learn with sustainable lunar development, with the SLD program? SLD, here, I'll show you how SLD is planning on getting out to the moon. Look. Why are you so annoying smart? Anyone smart? I don't know, Hexu. What? I would say yes. EJ is very annoying. Yes, I'm very annoying, but that's not the right diagram, but because that one has more Gateway copium in it. There's a graphic out there somewhere about how they plan on getting stuff out to the moon, but do you think a rectilinear halo orbit is the best orbit for Gateway? I think a rectilinear halo orbit would be a good spot for a relay. But here's the thing, dudes.
Oh, this is space. I'm in space.
I can't find that SLD graphic. Basically, you're going to have to take my word for it. Sustainable lunar development is a much better way to get out to the moon. It requires minimal refueling, couple of new Glenn launches, and you're on the moon. Like, seriously, 2 new Glenn launches will get you to the surface. Even HLS is better than this. 16 Starship launches. Now, I know what people are going to say. Like, 16 Starship launches is a lot, EJ. That thing is going to take 445 days to get... Gateway's going to take... On Falcon Heavy, it's going to take 445 days. If SpaceX can't refuel a Starship 16 times in 445 days, we have way bigger problems to worry about than landing on the moon maybe next year or the year after. Okay? See what I'm talking about? Gateway is literally the worst way to do this. And I'm tired of saying it's not. So, the thing about rectilinear halo orbits, dudes, is that not a lot of people know that on the moon, orbits decay. They decay. They do not... It is really hard to find what's called a resonantly stable orbit on the moon. The moon is not a perfect sphere. It is also kind of an oblate spheroid like Earth, but it doesn't have plate tectonics like Earth does. A really, really nice way of saying this is that the side of the moon that faces towards us is a lot denser than the far side of the moon because something smacked into it. Maybe an Earth did. We don't know for sure. Like, scientists don't know for sure, but they think the moon may have been part of Earth at one point, and something hit it and snapped it in half. Right? Like, not snapped it in half, but you get the idea. Or the moon itself was hurling through space and hit Earth and then captured. It's possible. But long story short, there's a lot more there's a lot more mass deposited on the close side of the moon. That's what those darker gray areas are on the moon. They're lunar basaltic regions. Basically, it's packed because something hit it. We don't know exactly what it was. Could have been us. We don't know. Something hit it. So that side is way denser. So it's really difficult to find like a perfectly circular orbit around the moon. Like say we wanted to go to low lunar. Low lunar is not sustainable. That is like trying to orbit the Earth at 100 kilometers circular, 62 miles. Unless you have some kind of great propulsion system, you're not staying up there for very long. The atmosphere is going to get you. Now on the moon, once again, you don't have an atmosphere, but you do have very strong non-uniform gravitational pull. This is called precession when it comes to orbiting around celestial bodies. Precession will get you. Precession will decay your orbit. So there's only a certain amount of orbits that require what's called minimal station keeping or minimal correction around the moon to be able to keep something indefinitely there in space for a long time. That's why Gateway has the power and propulsion element in the first place and why it's using ion thrusters. The rectilinear halo orbit is basically stable. It's using the moon to change its longitude of ascending node around the moon. So the rectilinear halo orbit will stay perpendicular to Earth. The orbit will stay perpendicular to Earth all the way around. That's what it does. But it's far enough away and it has the right eccentricity to also not be affected by these perturbing forces. And because we want to build a base at the South Pole, right, of the moon, they chose a highly eccentric orbit. And that high eccentric orbit, like that, affords the Gateway to be in line of sight of a South Pole base for an extremely long period of time. For basically like 7/8 of its orbit, it's in line of sight to wherever we want to build a base. So once again, fellas, the rectilinear halo orbit is not the worst idea. It's really not. It's one of those orbits that's very stable and it maintains constant line of sight with Earth. It's actually really smart. I don't have any problem with the rectilinear halo orbit. I don't have any problem parking something out there, like an EUS or something. I think that is just a poopy-doopy way of doing it. I thought there was an orbit that maintained line of sight with both the lunar base and Earth 100% of the time. I don't know how you're going to do that, uncapping. But yeah, 400 days. So 7 to 10 days to get into initial insertion. 300 days for the spiral subphase. 60 days for the alignment subphase. So we're at a year already, right? So we're at 370 days plus 30, 400 days, and 7 to 14 days for an insertion. 414 days. About a year and a month. Well, actually, a little more than a year and a month. Really? That a year and a month just to get that out there? Poopy doopy is best technical jargon. Yeah. No, I'm not the biggest fan of this. Like, I like Gateway. It's not a bad idea. This would be great for a relay station. In a relay satellite for the base, like put 2 or 3 things in rectilinear halo orbit, kind of, you know, 1 up here, 2 down here like this. So you're always going to be able to maintain line of sight. But I don't really, I think if we're going to send people to this would be like NASA sending people to Tidris if you wanted to get outside a low Earth orbit, which is what? That makes no sense. Just go directly to the surface. How many of those will we send up in total? Just one. It's a one-off design because, you know, designing things once for human spaceflight and making one has proven to be a very fruitful endeavor in the past, financially. Oh, wait. No, it hasn't. Cool. Jared will modify this, maybe? I don't know, man. I don't know. Anytime we do something with human spaceflight where we build one of something, it's not ending well. Look at Orion. They didn't even want to build one. They're building like 3 or 4 Orions. And now you have a problem with the heat shield. So you don't have another Orion in the processing flow to be able to test it. The next test has to be on a flight with people on it. Anyway, that's Gateway. That's its trajectory. I don't know, man. Hey, you know, like at the end of the day, if this gets it off the ground, that's great. I'll take what I can get, but we could have done this so much better. Like, and this isn't even a scenario of like perfect is the enemy of good either. This is like good is the enemy of poop. Like, we could have done this isn't like, oh, we could do it better. We could do it. No, this is a really, really backwards and roundabout way of getting to that orbit. But hey, we saved a lot of money by putting it on Falcon Heavy, I guess. What if it was 2 Falcon Heavies for each module? The Habitation and Logistics Outpost Erudite does not have power and propulsion systems. That's why it connects to the power and propulsion systems. It's basically just a tube. Is this just a we messed up the math and make it, but this should make it work now? No, this is we don't really have a good integrated plan, so this is what we're going to do. This way satisfies everybody. This seems like stage 2 after people are going to the moon regularly. That's Mowgli, that's exactly what I mean. Yeah. Yeah, Pop, I'm kind of done being like okay with this. You know? I've talked about it. Like I'm done being okay with it. It's stupid. This is stupid. There was a time where I was like, "Oh yeah, Gateway is great." Yeah, and once again, that time was like 2018, 2019 when we were supposed to launch it in 2022 and it'd be out here in 2024. Okay? In line with Artemis 3. There was there was a whole period of time where this was a good idea. Like, but here we are like 6 years later, and dude, this thing isn't even close to launching. It's not even close. Like, guys, the power and propulsion element is not that big of a deal. It's literally, not literally, it is actually based off of a satellite bus that is mass produced. Guess it's not mass produced enough. How much do you think Gateway will extend surface operations? I don't know. Why not go to an Apollo-style lunar orbit, build a base in an equatorial region, and then build a road to highway to drive down to the lunar South Pole? That way it takes 3 days to get to the moon. Equatorial lunar orbits don't work very well, Limprod. It's the lunar precession is going to perturb your orbit. I'm getting to it, Outdoorsman. But anyway, this is so frustrating. Yeah, it really is, Paul. Like, I'm kind of with you on it. Like, dude, there was a time where I was like, yeah, this is great. This is great. We're set to do it. But that's the thing. We were set to do this 8 years ago. Like, that, and this was supposed to already be out there by now. Like, where is it? And once again, I'm happy that we're getting to the point where we get a trajectory for the mission. That's great. I'll take what I can get. But also, I just can't help but think in the back of my mind, like, Gateway was on the books in 2017. What have you been doing for the last 8 years? Oh, wait. Forgetting to take into account the damn wire harness. Oops. Like, Yeah, anyway, let's keep going. More space news. Yeah, Isfil, that's really what I'm worried about. Like, the rate of progression just isn't good enough. It's not good enough to do spaceflight sustainably. The heck with even trying to race China. This is not... So, okay, let me explain something real quick. All right, a lot of people think there's an urgency here to get back to the moon, to beat, China there. That great. That's a good way. I personally don't think that's the best way to do things. Beating them would be great. That would be really nice. Like, as an American, I'd be like, "Brr, brr, 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 America," like, our way is better, like, or whatever, right? I'd be happy about that. But the truth of the matter is that even if China didn't have the moon in their sights and were, a potentially adversarial peer when it comes to going to the moon, this is not sustainable enough at all. Okay, so what do I mean? A lot of people throw sustainability around. What does that mean? What does sustainability mean? Okay, look. What was the first Saturn V launch? It was Apollo 4, right? And then there was a follow-up mission, Apollo 6. Those missions were there to test out the funnies that happened with the Saturn V. The next mission after that was Apollo 8, the next Saturn V mission, okay? All of these, so we had Apollo 8, right? And then we had Apollo 9, and then Apollo 10, and then Apollo 11 in pretty dang rapid succession, okay? Apollo 4 was, I think, 1967, all the way to Apollo 11, which was July of 1969, right? That is, so 4, 6, 8, 10, 11. That's 5 missions, 5 Saturn V's between 1967 and 1969. That's, so 5 every 2 years, all right? Don't get me wrong, if we'd kept going with that pace, that would have been great, but I digress. We kind of did, but the point is that all of these missions were leading up to Apollo 11. All of them were leading up. They were building to something. And flying quickly, relatively quickly, so every couple of months, basically helped pave the way. It helped make a concerted push towards getting that landing done. All right, that was a really important thing. One mission built off the last one. Where is that here? There's none of that here. We don't see any of this. Okay, in fact, Apollo didn't even put people on the Saturn V on its second flight. Not even Apollo did that. And Apollo was, by today's standards, Apollo was borderline like negligent, right? Now, don't get me wrong. We have SLS, and SLS is based off the shuttle tech, so it's pretty matured technology, et cetera, et cetera. Okay, so if that's the case, why aren't we making them more? Why we should be able, by that logic, we should be able to make more of these things, right? It's matured tech. We know how to do it. We can make them. We've been making SRBs for 30 years for the shuttle program, right? Where is this progression here? This progression doesn't exist. It doesn't. We don't have an Apollo 4. We don't have an Apollo 6. We don't have an Apollo 8. Artemis 2 could kind of be attributed to Apollo 8, but Artemis 2 is like Apollo 7, 8, and 9 all rolled into one mission. It's testing Orion with people on it, which is what Apollo 7 did. It's testing proximity operations, which is what Apollo 9 did, right? And it's going out to the moon for a free return like Apollo 8 did. It's 3 missions rolled into one. Why do we think we can do that? Seriously. There's no progression here. Do we honestly that's what I mean by sustainable. There's no progression here. There's no steady rate here. There's nothing. Launching once every 18 months is not a good way to conduct spaceflight, period. It's not. It's not, especially if you're trying to push the scientific frontier. That's not sustainable at all. You're not, by the time you get ready for your next flight, all the stuff that you learned from that first flight is gone. Like, you have to retain that knowledge for a certain period of time, and then you have to put it into the next flight. Like that, you're there. You're losing your. That's just enough, right? It's just enough to kind of keep the status quo. It's not enough to push the boundaries, and that's not good. Like once again, don't even involve China. Like just put them over there. Like say they want to go somewhere else, right? Say it's just us trying to go to the moon. Going to the moon once every 18 months is no good. That's not going to get us anywhere. There's going to be no crazy scientific advancements, and if there are, the rate of progression is going to be so slow that we'll figure out some cool breakthrough maybe in 40 years, right? If I had money to carry out all those tests. Nah, Hellfish, no. No, I disagree with that. A lot of the money went into building the infrastructure to build super heavy launch vehicles. That's where the vast majority of the money went. That infrastructure already exists. So, nope, the money is there. I will say this once again. The money has always been there. It's a programmatic failure. That's why I have problems with the gateway. It is a programmatic failure. All right? You are not giving your NASA is not the way they have this all set up. They're not giving their engineers the tools that they need to succeed to conduct a healthy and strong space program for lunar exploration. We're really not. Like that's the truth. I'm sorry. Like I know that's going to piss somebody off somewhere, but and that needs to be changed. Forget racing against China. Forget racing against them, dude. We're not even poised to race them in this position with this type of launch rate. We're not even poised to race them. We will absolutely not absolutely lose, right? We might get there before them, but dude, okay, great. We get there before them with our program that's supposed to be super sustainable, right? Say we get there before them. Say we beat them there. We get there in 2028 and they get there in 2029. Let's just say, I mean, that's kind of an outlandish thing, but let's say that does happen. All right, great. We get there. Do you think China's going to go there once every 18 months once they have a way to get to the surface of the moon? No, absolutely not. What are they doing? They're sending another mission as quickly as they possibly can to show that they could do it again, right? That's exactly what they're going to do. Why wouldn't they? Like, what are they going to do? Do it once? They're not doing it once. Don't kid yourself, right? Why nobody's thinking about that is beyond me. I don't get it. Like that's not even like kind of catching up on the VOD, but I just wanted to say by the time we get Gateway out to the moon and it is up and running, I'm willing to bet we have starships on Mars. Sledge, I understand the hyperbole there. The point, I agree with you. I really hope, but say NASA does that timeline, right? And Gateway gets out there in the next, 2 years. I really hope we have a better way to get there. I really do. Because if we don't, we got some big problems. Yeah, Element, that's what I'm trying to say. Even if China didn't exist as an entity, even if we weren't space racing them, this program sucks. It's a terrible way to do things. And I'm not even saying that the hardware is the problem. It's just the way the program is set up. You're not hardware rich. Hardware rich is no way to conduct a space program, especially one that's going to push the scientific boundaries. That's no way to do that. No, we got to ramp up. It has to be more. Dude, we need more. Like, and I'm serious. People are gonna look at me funny. I mean, some of you in the back is already doing that, but it's okay. I mean, more people are gonna look at me funny. I think we should launch SLS more. We need to launch it more. Do that Gateway EUS thing that I'm thinking about. Just hotwire a power and propulsion element to an EUS. See the frick what happens. Right? Worst case scenario, your EUS just makes it out there, and then an Orion conducts a regular mission out at the moon. Right? You don't just like say, oh, this is going to be our fundamental transfer vehicle. No, you do small upgrades over time. That's what Apollo did. That's how we ended up getting, lunar rovers. driving the lunar rovers around, more fancy ALSEP experiments, upgraded Saturn V. Like, that's the way to get it done. At some point, you got to fly. You have to fly more. Flying 18 months is not going to teach you. It's not going to teach you anything. It's not going to be good enough to even keep our own program running sustainably. So the point that I'm getting at is that if we continue flying on this pace, we're going to launch Gateway out there. It's going to get out there, and we're going to go to it like once every 2 years. No. People need to be going to Gateway every 3 months if it's going to go out there. Every 3 months. Every 3 months, we need people out there getting out there, doing science, getting our money's worth for that damn thing if we're going to use it. See what I'm talking about? That's what needs to happen. And that's not going to take a lot of money to ramp like that. We have all the systems made. Everything is there. We just got to want to do it, you know? Do you think Starship will be able to dock to Gateway? The Government Accountability Office doesn't seem to think so. You mean to say that the absolute cutting of science and space programs, NASA and everything is actually not good? It's a clown show. Not exactly, Acidil. No, that's not exactly what I'm getting at. Don't get me wrong. I don't think that's a good idea either, to be 100% honest with you. I don't necessarily think that that's a good idea. However, if we really want to play that game, you know, NASA's science budget has been getting the shaft over the last 4 years. If you really want to know, Chandra got axed. Thousands of people laid off, maybe not thousands. I don't know the exact number. A lot of people laid off at JPL. Viper got axed. What else? There's a lot more. Yeah, the science program has basically gotten the shaft. Like, you know, contemporary budget requests notwithstanding. It's ridiculous. It's ridiculous, man. Why is Artemis 3 taking 3 times the number of super heavy lift rockets to do the same thing Apollo 11 did with one rocket? That's what I'm getting at, no good. That's what I'm getting at. This architecture sucks. It sucks. Whoever thought this was a good idea needs to be slapped. Like, I'm talking like, you know that meme with Batman where he's like, boom, Robin, no. You know, like, it's so bad, dude. You could do all the fancy simulator stuff you want. It won't give you a tenth of results you get from actually flying. Bingo. Acid, you want to hear something crazy, dude? I don't think that NASA needs to be, I don't think their funding needs to be increased or decreased. NASA gets $23 billion a year. That's billion with a B. That's more than enough to do what we need to do. We just need something to tie it all together, just like we did during the Apollo program. Something needs to tie everything together. The Apollo program tied all these NASA facilities together, the science missions and the human missions. They all got tied together. That was the right way to do things. That's why James Webb has a space telescope named after him, because he was the brainchild that thought of that. We need to do stuff like that again. Because right now, all the NASA design centers are kind of scattered to the whim. And that makes easy pickings for programs to get canceled. Because if there's one program at one NASA center that doesn't depend on any of the other NASA centers, someone's going to go after it. Right? Simultaneously, if you have a program that depends on multiple centers like SLS or the Artemis program, that's a little bit harder to go after. Right? But if you take something like SLS and you champion it and you farm out, you expand it and you farm it out to as many NASA facilities as you need to, well, either A, no one's going to try to go after and cancel it. You know, that's the absolute bottom tier. Or B, you try to farm it out to as many facilities as you want, and everybody gets on board to ride to get this money to ride the gravy train, right? Make the gravy train work for you. That's what I'm trying to say. Like, this is just, it's bad architecture, dude. It's really not good. Like, here's the thing, all right? And I'll put a pin in it after this. I'll shut up, I swear. Here's the thing. So, I probably won't shut up. I'm sorry. I'm not going to lie to you. I'll get to more space news here in a moment. The Artemis program and how the Artemis program is set up, you know, SLS with the interim cryogenic stages, and then EUS, and then building Gateway with Orion, and then building a lander eventually to get us back to the moon. That is okay architecture. It's not bad. It's not... Apollo was arguably better. It's not a bad way to do it if you're flying 4 times a year, but you're not. You're flying 4 times every 5 years. Empirically. That's no good. No good. We've seen rapid testing with work both from the Apollo program and from Starship. Clowns at Artemis still don't understand how rapid testing works. Yeah, that's what I'm saying. NASA needs to go back to doing that, and some people aren't going to like that. People won't appreciate actually having to do work again. But that's where we need to go. That's where the Artemis program needs to go. That is not even to race with China. That is just to run a good sustainable exploration program. Because flying once every 18 months ain't going to get you anywhere. Think about like employee turnover, dude. Somebody's going to, stay at NASA, right? Get one SLS launch under their belt. And because they have an SLS launch under their belt, they'll get poached by the private industry. And then you have to deal with job turnover. And now you're dealing with replacing the job. People move in and out of the job market all the time, especially in the aerospace industry. People move all around. If you know. The aerospace, everyone knows everybody, so everybody moves around in the industry. People that work at SpaceX end up going and working at Blue, and vice versa. People that work at Boeing go and work for Lockheed or ULA, or people that work at ULA end up going and working for SpaceX, or vice versa. People move around. So you're going to have to deal with this crazy turnover rate. Launching once every 18 months, no one's going to do that. We already beat China to the moon. How is this a space race? Because they want to build a base there? Yeah, people want... The U.S. government doesn't want China getting there because, the moon is the ultimate high ground, basically. It really is. It's an influence game. Again, yeah, we already beat them to the moon, right? But that's like saying the Yankees are a good baseball team because they won a World Series in 2009. No. Oh yeah, you've won the most World Series. When's the last time you won one? Oops. You know what I mean? Sorry, I'm a Red Sox fan. We suck too. Sorry. Bad example. People that work at NSF go work at SpaceX. That's a good point, Paul. I know a lot of people that work there now because of NSF. Yeah, dude, I'm a huge Patriots fan. Just because they won 6 Super Bowls, good. What has that meant in the past 5 years? Nothing. We suck. We're terrible. That's a great example. I'm even willing to talk bad about my beloved Patriots because it's worth it. It's worth it as an example to show people why this is dumb. This is dumb. This is a stupid way to do things. The Artemis program is the freaking Mac Jones of freaking spaceflight architectures. It seemed to be a really good thing at the beginning, but the further and further you got into it, it sucked. It's terrible. It's true. Dude, that analogy holds up way too well. I don't like how realistic that is. I don't like how real that is. That's not good. D21 12-month reset. Thank you. We sent our coach to UNC. What are we doing? How's the Bruins? Exist? They exist. Oh wait, they don't. They don't. My hockey season ended last week. Oh boy. Anyway, sorry. That escalated quickly. That rant really got out of hand. If SLS doesn't get canceled by Artemis 4, these shuttle-derived technologies are up to 40 to 50 years old. Do you think they'll be sustainable for NASA? Cheeseburger, that's actually a really good point. Using technology that's pre-existing as a stopgap to try and work. So like okay, the space shuttle is using engines, the AJ-10s that were part of the lunar program. But the shuttle program had the OMS pods that were using a very similar design to the Apollo Command Service Module, similar engines. The RS-25s are derived from a J-2, right? Like that's a good idea, using what you have left over, right? Not a bad way of doing things, but that is there to build it quickly. Right? The whole point of the Constellation program using Ares 1, whether you love it or hate it, personally, I love it. I think it's a great design. The whole point of the Constellation program was to keep not just jobs, right? But to keep the technical expertise. You keep the technical expertise. The people that have been launching SRBs for 30 years are going to be very good at adapting that technology into a single stick design, like Ares 1. And then the technology will carry over even more into Ares 5 because it's double launch technology, just like the shuttle. It's a shuttle-derived vehicle. That was the whole idea with the Constellation program. You know, it's not just about retaining jobs. It's about retaining your technical user base. All the people that have been working on the shuttle program, that know how to launch these things, that know how to put them together, that know how to do it quickly. All of that knowledge was supposed to be carried over into the Constellation program, and we lost it because we canceled it, and then we canceled the shuttle program right after it. Dude, the day after STS-135 landed, 4,000 people at KSC got a pink slip in their locker. 4,000 people. And then what do we expect? Just because you put SLS on the books that these people are going to come back and being like, oh yeah, okay, cool. You just canned me after 30 years. All right, this is great. Yeah, I'll come back. No. What are these people going to sit and wait around in Titusville for another job? No, absolutely not. That's not how that works at all. And we lost that technical base. And basically, part of the reason why SLS has taken so long is because we've had to relearn it. We're relearning an antiquated system to make a near future system, which is, once again, a super roundabout way of doing things. It's very frustrating. It's okay. Constellation was a good idea because it overlapped with the shuttle program. So as the shuttle program is ramping down, you just move people over to the Constellation program and you're good to go. And then you bring more people on board after that when after you start launching a lot. You bring more people on to develop vehicles. Heck, even Ares 1. Ares 1. So, okay, you guys really want me to screw with your head a little bit? If you know a little bit about Constellation, and you're a little bit of a spaceflight fan, one of the biggest criticisms of Ares 1 at the time, hang on, I'm just getting some pictures up for you guys. One of the biggest criticisms of Ares 1 was it was going to carry a ridiculous cost. The cost of launching an Ares 1 was going to be so damn expensive. It was going to be so expensive. It was going to be super expensive. Everybody said that. And that, yeah, there is some merit to that. Do you know why? Ares 1, this thing in the center, this tall boy right here, Ares 1 is carrying the development costs for Ares 5. Okay, look. Ares 1 uses a 5-segment SRB, right? The shuttle used 4-segment SRBs, right? Ares 1, Hydrolox high energy upper stage using a J2, all right? That's a big deal. That's a lot of development. This was going to be expensive to make, but it was going to be expensive to make because you're building new technologies. One of them is derived, so you can at least push the cost on that because you've been launching SRBs for 30 years, right? But the J2X propulsion on paper was roped into Ares 1 development. J2X propulsion, which would have made that thing up there, the Earth departure stage. That's what we were going to use to go into deep space. So the development for this thing, you get to develop Orion, you get to develop cryogenic high energy upper stages again, and then a 5-segment SRB on top of that. All of these technologies were going to find their way into Ares 1, Ares 5, excuse me. to basically offset the crazy cost of building something like this with a 10-meter core that can move 180 tons into low Earth orbit in one shot. You're going to offset your propulsion development. So Ares 5 would have been cheaper to make. That was the whole idea. And all of that was going to utilize what we learned from this thing. All the people that worked on the shuttle were going to end up working on Orion. All the people that worked on the SRBs are going to end up working on SRBs. All the people that worked on MPS, propulsion, right? We're going to work on J2 and then ultimately Ares 5 with the RS-68s here. That was the whole idea. The whole idea is you take your entire technical expertise and you rope it into developing new vehicles, utilizing technologies that already exist. But more importantly, utilizing the people that know how to use that technology, right? That's the whole idea. That's the whole point. We love a good stick. I love stick rocket, man. Ares 1 and Ares 5 are going to work in the same exact way that the Saturn 1B and the Saturn 5 did. Saturn 1B was launched first, and it was launched a lot. And what they learned there from flying a lot transferred right into the Saturn 5. Heck, Saturn 5 and the Saturn 1B ended up having the same upper stage. Can the Artemis program be saved and converted into something actually good? If yes, how so? Yeah, sedated, I know. It's annoying. Well, what if Ares 5 bad? Oh, well, yeah, you're right. Maybe we shouldn't do it anymore. So no good. Could the Artemis program be saved? Yes, sure. It's going to require a drastic kind of revamp, and that's going to come. Here's EJ's prediction. Some of you probably won't like this, okay? And it's going to sound screwed up saying it, but here's where I'm at. SLS needs to be canceled. Not the procurement contracts need to be canceled. The program doesn't need to be canceled, okay? I said that to get people's attention. That was a little bit of a hyperbole on my part, okay? The procurement for this is terrible. Terrible. One launch every 18 months? You got to be kidding me. No. No good. No good. Here's how I fix it. Here's how you fix it. You change the incentive for operating on a regular schedule. I want 4 SLS launches a year. That's really what we need. 4 SLS launches a year. That's not a hard sell. It really isn't, considering we have the entire factory and industrial base for building SLSs already made. Not going to cost that much more money, right? If anybody's going to go, oh, well, we can't build it that fast. You sure? We were building, you can't build RS-25s that fast. We were building them this fast before. How about if we give you an extra $100 million for completing it, for getting it done quick, right? We're already going to piss away that extra money, by just sitting here doing nothing anyway, right? You start incentivizing stuff to get done on a quicker schedule. Now, I know what people are going to say. Well, if you do that, isn't that, aren't you getting a little bit of go fever? Well, yeah, absolutely. I'm not saying put people on the next 4 SLS flights either. I want a year of unmanned test flights, just like Starship. Test this thing. Do 4 more Artemis 1 missions just to be absolutely sure. Then put people on it. Enough to get your industrial base to stabilize over time. Basically, once you repay them to start ramping up, and then they ramp up, and then you build up those progressive build-up missions exactly what I'm talking about, and you build up to launching SLS Block 1B 4 times a year. From there, right, after all those incentives paid out, you're going to have some capital to play with, right? Because you're going to get constant funding, right, from Congress. You're going to get constant funding. From there, you use that to fund a lander. An in-house NASA lander utilizing hypergulls that hedges your bet against SLD and HLS. And I know people are going to look at me like I'm crazy. Dude, what are you doing? What am I doing? Can anybody honestly say that Starship HLS is going to happen in the next year? Next year and a half? 2 years? What about SLD? That's not happening till the end of this decade. You hedge that as a way to get the commercial market to build landers for you faster. Gets done faster. Now, once again, people are going to say, oh, well, the commercial people are going to rush their landers at that point. Okay, great. They have to test them, remember? They have to do uncrewed tests. If it doesn't work, fine. Yeah, guess what? You gotta send it again. Didn't work that time. No post-flight certification for failure bullcrap like what Boeing's trying to do with Starliner. No way. If it doesn't work, you send another one. Hey, you signed up for this. Which was going to be the plan anyway. Controversial solution to the build speed problem. Give it to Elon. No, I wouldn't do that, uncapping. I don't want Elon anywhere near NASA, and I'm saying that as a gnarly SpaceX fan. Have Elon and Starship do their thing. Have them do their thing. No. We need somebody to run NASA like with some motivation, with some damn purpose behind them. We need somebody running NASA like that, but not him. No. And I don't hate Elon by any means. Right? I like SpaceX, but I want him doing SpaceX things. I want this. I want this kind of stuff. That's why I don't necessarily think Rook is a bad pick, because Rook understands that, and I think that's what he wants to do. But I don't know for sure. Imagine how many Voyager probes you could eat out there on top of an SLS. And if it's launching on a regular schedule, Aqualux, guess what, dude? You get to that point, you have 4 SLSs available on tap. First one goes to the moon. Does a long duration stay. Does a 6-month stay. We'll get to doing long duration missions. Launch the second one with science probes. Launch the third one to the moon. Launch the fourth one with the station module or something. Or a transfer vehicle. The EUS transfer vehicle idea that I have is borrowed from the Apollo applications program. It is a very good idea. Because it's not my idea. It's Von Braun's idea. He was pretty good at rockets last time I checked. Do you think Jared would actually restructure Artemis to be geared towards rapid launch cadence? Yes. Rook has said many times on X how NASA doesn't have a budget problem. They have a capital allocation problem. And he's absolutely 100% correct. I wholeheartedly agree with him. We're spending money on all this stuff that really doesn't go together, right? No, I get that and agree, but realistically, I mean, sincerely, who else is there? Mike Griffin would have that would have been my pick for NASA administrator. I would have picked Mike Griffin, to be honest with you. Mike Griffin was the NASA administrator during George Bush Jr.'s second term. He's the one that oversaw the Constellation program. Not only did he oversee the Constellation program and get it running on a relatively good schedule, a relatively good development cycle, to the point where the first prototype launched in 2009, Ares 1X, that albeit after he did leave. Mike Griffin had to deal with the return to flight mission after Columbia, right? So he got the shuttle program all patched up and working on a regular schedule, and also got Constellation development kicked off at a pretty damn good pace at the same time. Mike Griffin got the shuttle running on a regular schedule, 2 to 3 times a year. From 2005 to 2011, shuttle program operated on a regular schedule, just like it was intended to, and it built the damn space station. He's the guy that facilitated that whole thing, on top of organizing the Constellation program. He would have been my pick for administrator. Rook is a good idea. If Rook tapped Mike Griffin, I would lose my mind. Because Mike knows how to run a space program. That dude, I don't know the man personally, but damn does he know how to run a space program. D-Drain, hey, found you. No, I found you just now. Oop, drop. Who is Rook? Rook is Jared Isaacman. That is the current president's pick for NASA administrator. He will be voted on whether he gets confirmed as administrator in about a week and a half, somewhere in there. Rook is his call sign. Yep. Anyway, yeah, guys, that's that would have been my pick. That's who I would have tapped if it was me. If I was in the president's position, that's what I would have done. Mike could fix that. He could step up. He could step it up. He did it before. Been following you on YouTube and on NSF. Hey, D-Dring. Yep. My favorite idea, station module plus node permanently attached to the top of an SLS core. Fill a module with flat pack. Get the whole core to orbit, wet workshop the SLS core and furnish it with the flat pack. I mean, Aqualex, dude, if you're launching 4 times a year, eventually you're going to move to longer duration stays on the moon. Just saying. It's totally doable. Anyway, let's keep going with space news. So this is coming from iSpace. iSpace has a lunar lander that is actually moving out there. This is the Hakuto RM2 mission. Resilient status, nominal. Distance from Earth, about 345,000 kilometers. Current orbital phase, low energy transfer. Traveling at 4,300 kilometers an hour. Next up. With an upcoming burn plan for April 24th, we are expecting to complete all deep space orbital control maneuvers before lunar orbit insertion, and thus success 6 of Mission 2 milestones later this week. Cool! Hakuto RM2 is almost there. Cool. Excellent. That's cool. That was one of 3 lunar landers that's already been launched this year. The other one being Blue Ghost, which is Fireflies, and Intuitive Machines 2, the Odysseus lander. Blue Ghost worked. The Nova C one, that tipped over. But it made it. It's in one piece. It's just on its side. So hopefully we go 2 out of 3 here. Well, the front fell off. Yeah, don't worry. It's been removed from the lunar environment. Anyway, good stuff. So, here's another thing from NASA. Don Pettit, on his 70th birthday, touched down on the Soyuz MS-26. Touchdown with from the Soyuz MS-26 mission. He was relieved by Johnny Kim, who flew up on MS-27 a week ago. He came down late last night. Don Pettit, the oldest, NASA's oldest current astronaut. I think this may have been his last mission. He turned 70 when the capsule was re-entering, believe it or not. Dude, look at the flying potato up there. Can we get Moldy Space for some crazy SLS ideas in Kerbal? I don't think that's a 28. I think that's an MI-17. Yeah, it's an MI-17. Not a bad helicopter. It's literally the box truck of freaking helicopters. But it looks like they got some, Huh. I wonder what that's about. But anyway, Don Pettit did come down. Yeah, Mi-28 is that's an attack helicopter. I really, really, really hope they wouldn't have that flying around when a Soyuz came back. That would be a little weird. According to NASA officials at the landing site, Don Pettit is doing well and in range of what is expected for him following the return to Earth. Yeah, there were some pictures of him landing, and he didn't look too good. But you know, you got to remember the dude's 70, so you know. And this is what I mean. If you guys watch the Flame Trench here the other day, I was talking about comparing astronauts to commercial entities. That's Alexei Ovchinin right there. And then Alexei Ovchinin was the commander, and then Ivan Wagner was up there as well. Spaceflight is hard on your body. It is very, very tough. Doing stuff like this is not just going up and coming back down, dudes. It is not the same thing. Yeah, you got a chocolate egg. Like, these guys are sitting in the chair, dude, because if they try to get up and walk, I mean, even coming out of Dragon, they take them out on the stretcher. There's Ivan Wagner. Dude, do you have a... Is that a Matryoshka of Alexei Ovchinin? A Russian nesting doll? Huh. They didn't really show Don Pettit too much. He wasn't doing great coming out of the capsule, but that's because space and re-entry beats the crap out of you. It's no joke. Trying to back it up, see if we get... Yeah, see? Spaceflight really screws you up. That's them getting Don Pettit out. I think. That might be Yvonne. Nope. Here, let's see. You have nice egg? Yes, very nice. Didn't Yvonne do a short stay with the Japanese guy from the mission that Tim Dodd was going to... Yeah, Deer Moon. Yeah, what's his name? Yusaku Maezawa. Yeah, that was Don Pettit. Did you see, like... This is what I mean, dudes. Spaceflight knocks the crap out of you. Like, you know, some of the Blue Origin astronauts, and once again, they can call themselves whatever they want. Like, I really don't care. It really doesn't bother me. But you can't compare yourself. You can't compare yourself to Alan Shepard. You know why? If you flew on Alan Shepard's flight, you'd be in the damn hospital. This stuff messes you up if you're not careful. Look.
And Don Pettit now being extracted.
He's like, I'm good. I'm all right. Now, fortunately, Don Pettit is in good health, but he's... Yeah, dude, it messes you up, dude. Deer Moon got canceled, yep. Chocolate egg. And then they're gonna get Ivan Wagner out here.
Alexei Ovchinin and Don Pettit out of the Soyuz vehicle.
Wagner's a pretty funny dude. Like he was up there when Bob and Doug were up there for when they launched up on DM2. Look at this guy. He's like, hey, what up?
And Ivan Wagner now out, being placed in his chair. All three crew members out of the Soyuz.
There you go. So that was MS-26, Don Pettit back home. I am pretty sure that's going to be his last flight. But who knows? Who knows? Now, he's not the oldest guy to launch into space, though. To be 100% honest, that was John Glenn. But that's up there. How did they extract the astronauts from the shuttle after the return? The pilot commander has to do a lot of climbing over consoles based on the layout, if I remember right. They took the crew on the mid-deck out first, Nader, and then, yeah, they installed ladders. There was like a step ladder that you can install to get up to the flight deck. So you'd usually have 4 people up on the flight deck. 4 people up on the flight deck, 3 people on the mid deck. Egress all the people out of the mid deck on the shuttle, and then they put the ladder in, get the 2 people that are sitting behind the pilot and the commander, get them out, and then their seats actually are removable. You could just unbolt them. You could the seats are the padding on the shuttle. The padding is built into the suit. So their seats just look like folding chairs on the space shuttle, believe it or not. It's not, it really doesn't look like much. So they would take the chairs out and they would install a ladder. I know because I've climbed up said ladder, if that makes any sense. Yeah, they had the ladders that they used at the Museum of Flight when me, Scott Manley, and Das got to go into the shuttle trainer there. Yeah, they had the ladders to climb up to the flight deck, because you're not going to need you don't need the ladders when you're up on orbit. So how did they get up and out of it? They you take parts of the seat out, if that makes any sense. You take part of the seat off, so you're not climbing up over the center console on the shuttle. So like the seat back can be removed, and then you kind of just do that. If that makes any sense. Yeah, you can remove the seat back. The shuttle seats are not, they're not what you think, guys. They're not like some cushy airliner seat. They're not. They look like a folding chair. They look like they're made out of extruded aluminum. Is Don back in the States? He's coming back. He's probably almost home, but yeah, they'll be back soon. Here, I'll show you. Don't ask me why I remember the shuttle egress operations. That was, yeah, it's just weird. Recall that off the top of my head, but give me one sec. Does the VR 360 thing not work anymore? Oh, it doesn't work. He's home? Good. He's already back? That's good. Good. Yeah, they got him home quick. Yeah, I'll just find a picture of the flight deck. Hold on. Yeah, it's not what you think. The seats are... basically folding chairs. Like, check it out, dude. So you'd undo them right here, and you basically, they don't necessarily move back. Ben Cooper took this picture, by the way. But you basically do this, and you get up and over. For the most part, like it's not that bad. Now, those are the seats that are on the flight deck. Those are, believe it or not, a more permanent fixture. The seats on the mid deck, you could just fold them up. Yeah. Give me one sec. I'm seeing see if I can find a good picture. Hey, Tarek. Which shield tours? Is this it, Lemprod? Yeah, here we go. Yeah, see, you can undo that right there, and the thing will basically just fold back. Now, if we go down to the mid deck, see, look, the seats are just, that's it. They just fold. And then where's the dang old ladder that I was, well, there's the strap for it. That's the head right there. But the ladder attaches over here and you can climb up. There's 2 ways to get up there. You could go over here as well. There's 2 ways to get up to the flight deck. That's the kitchen over here. That's the pantry, believe it or not. Right here is radio. That's radio communication, so you don't need to be up on the flight deck. Yeah, shuttle had an oven in a kitchen, sink. It had a toilet. It had a head over there. There it is. Yeah. It's like the size of a porta potty. I mean, dude, I'm telling you, this thing was riding in style. This is the 3rd deck. Not a lot of people know that the shuttle has 3 decks. This is where the shuttle held its water tanks. Yep, water tanks down here in the 3rd deck. This is inside of the pressurized volume. Yep. Also, the avionics bay is right in front up here. It's behind those lockers. So if something did go funky with the avionics when you were on board, you could just take this, just move the lockers out, and you could get at your avionics package. See? All the avionics were inside of the pressurized volume. So were the life support systems. Smart. Very smart, actually. Yeah, that's why the seats can be stowed and folded up. Because, yeah, there's not a lot of space for 7 people in here, dude. Goltech, 7213 sub. Thank you. Yep. She's a beast, dude. I mean, this thing's really riding in style. This thing is nuts. It's a complicated system, but dude. Thing's beast. Yeah, okay, here's the Canadarm controls. The shuttle had a whole closed-circuit television system built into it. There's 4 cameras at each corner of the payload bay, 3 cameras on the robotic arm. This is your remote manipulator system controls right here. This is the RMS control board right here, so the operator would be right here. There's your camera views, right? And then there's a tertiary camera view over there. Yeah, docking system powers over here. So this is the SSRMS control board. Let's see if I still remember this whole thing. Yeah, okay, so check this out. So the shuttle had the ability to fly with two robotic arms at once. You could have one on either side, and you could use them to attach and put stuff together. They never did it, but you could. You have a starboard RMS control. This is the, what the heck is that called? The manipulator positioning mechanism. That's what this is. This is the MPM. So you have one for port and one for starboard. These mechanisms down here, inside of the shuttle's payload bay, the arms actually had to be stowed in for the payload bay doors to close. When the payload bay doors open, the MPMs actually move the arms outwards. So you can reach into the payload bay and pull stuff out. This is your kinematics controllers up here. Yeah, the shuttle, the Canadian robotic arm used IKs, but you could shut them off. This is individual joint control. And then the cool thing about the robotic arm is that you can modulate power between the joints. The arm was actually equipped with servo power amplifiers. So you could, if you needed more torque on the elbow, right, you can get more torque on the elbow. You can modulate power. That's what these control. That's individual joint control. And then power, I believe, is up there. I don't really remember too much. Yeah, the shuttle was beast mode, dude. This thing was amazing. Like, there's a reason why I love it so much. It's absolutely bananas. Like, that's what a spaceship should be. Like, that's a spaceship, dudes. Here, check this out. while we're here, let's take a little peek. Going to the payload bay. So your manipulator positioning mechanism is these things right here, these Dorito-shaped things. The MPM is over there, and then the arm attachment point is right there. See it? But if you look, there's one on the other side. But it's all modular. That's the craziest part about this. It's all modular. So if you wanted to carry no arm, you could carry no arm. You wanted to carry one, you could carry one. You want to carry two, you could carry two. It's not a big deal. The shuttle payload bay had bulkheads here. See these things? And then on each bulkhead, you basically had a power tap, right? And the main wire harness for the space shuttle goes down here. It's underneath here. And what you could do is you could reconfigure the shuttle's payload bay. You could reconfigure it by moving the latching system, right? So you could take this latching system and you could move it to this panel right here. The front part of the latching system bolts to the bottom bolt hole, and the back part of the latching system bolts to the back one. So you could take these things out and you could reconfigure them wherever you needed them to be. Also, you have payload bay power here, so if you needed to power a module inside of the payload bay, you can, no problem. These pins right here are the Longeron pin passive latch system, okay? Well, actually, that's your passive latch system. That's your active one. This right here, right there, is just a locking mechanism to hold something inside of the payload bay. That's a passive latch. No power required. The active latch right here needs the power connected into it, right? And you could connect it in. You just swap it out like Legos. That's what the OPFs were used for. You swap this stuff out like Legos. So you could change around where the different types of payloads attach. So you could launch basically anything inside of the shuttle payload bay. You could put whatever you want in there. Anything that can pick up on these pins, sure, no problem. If it requires power, put a power board up there. Tap it into the main harness, no problem. Plug it in, you're good to go. Heck, you could even backfeed into the shuttle's power systems. They did that. They had a power module in the payload bay in the 90s called the EDO, the extended duration orbiter. It was basically a bunch of extra consumables for the fuel cells that backfed into the shuttle's power systems, so the shuttle could stay up there for longer periods of time. I'm telling you, man, this thing was nuts. The shuttle is insane. It's so ridiculously well thought out. It pisses me off that we don't use it anymore. Even by today's standards, this is pretty trick. This is pretty well thought out, dude. Dude, tapping into different power and stuff. Starship's going to have to do stuff like this, man. You're going to have to figure out stuff like this if you want Starship to be used as a commercial launch vehicle, or if you want it to move rovers or payloads or whatever to Mars, right? You have to be able to configure the payload bay, which is why I think that Starship is going to have a payload bay that ends up resembling this in some way, shape, or form. Because this is just too well thought out to not do. It's just too smart. Seriously. You have power taps right there. These see that thing right there that looks like a docking port? That's a power tap system to tap into a module, right? If you need it powered, right? And then you need to take it out and attach it to the space station. You can unplug it from the payload bay remotely, right? And then use the RMS to put it in position. So cool, dude. Sorry, trying to get Chris B. Shuttle horses. Yeah, I got you. I mean, I'm telling you, man, this thing is nuts. The shuttle is beast mode. This thing is so damn cool. It's a shame. It's a shame we stopped using it. And it's even more of a shame that we lost the technical expertise as well. SpaceX is trying to relearn it right now with Starship. They'll figure it out. But, man, in case you're wondering what that is, it's a light. There's 6 lights in the shuttle's payload bay. They're using like a quartz lens. There's 2 up at the front right there. So 1, 2. This is the midship lighting. 3, 4. And then 5 and 6. Yeah. Quartz lenses. These gold hooks there are for EVA operations. There's 2 slide wires on each side. There's basically a metal wire that runs from here. It's not run in this picture. Once again, all configurable to there. It runs to right there. And an astronaut that's EVAing can attach their harness to it, and then you can move around in the payload bay and you don't have to worry about floating away. Dude, I'm telling you, man, this thing is insane. The shuttle's nuts. It's an absolute beast mode of a vehicle. And it's all reconfigurable. This thing could launch anything. It could launch a gigantic truck-sized tuba into space if it needed to. You could put whatever inside of the payload bay. Anything you can fit. Anything that can fit inside this payload bay up to 25 tons will fly. Anything. And I mean anything. The whole thing is designed to fly with differential mass inside of the payload bay. If you're a Kerbal player out there, I want you to think about that for a second, okay? Can I put my dreams and aspirations in there? No. You'd have to go find the trash bin. Just kidding. I want you to think about that for a second. The shuttle could launch into space with no payload in it or with 25 tons of payload in it. It could do either one. And it would launch the exact same way every time on an asymmetric launch vehicle. If you're a Kerbal player out there, try doing that. Try doing it. See what happens. It's not an easy thing to do. That's really complicated to get that right. Crazy, right? I'm telling you, man. It's a beast. The thing is ace. Sane people don't cook up something like this. You could launch it with nothing. You could launch it with a school bus. You could launch it with 25 tons of lead. It'll fly exactly the same. On ascent. When you're coming back down, you only have 12-ton down mass. Excuse me. The reason why is because whatever you put back here basically needs to fit in the back half of the payload bay, because, the shuttle does that whole glider thing, landing on the runway thing, and for it to I wouldn't call it fly, right? But for that, falling with style thing, you need to have your center of mass and center of lift lined up. If they're too far out of whack, it won't do it. So you're only limited by, you could bring down whatever you need in half of the payload bay. So whatever you can fit from here back, whatever you can fit basically in the picture, if it fit inside of the shuttle's payload bay, it could bring it back down. Yep. Up to 12 tons. I'm telling you, man, this thing's a monster. It is this. If we had just launched this thing more, or figured out a way to remotely operate it, that probably would have been the best thing to do. But yeah, for a brick, it flew pretty good. That's right. Oh yeah, the shuttle is also capable with egress capability. It has an airlock built into the design. Fun fact, the airlock is removable, so if you want to launch a shuttle with no airlock, you don't have to. Another fun fact, say you have a payload bay that's full and you still need an airlock. The airlock can be put inside of the payload, or put inside of the pressure vessel on the middeck. Not a lot of people know that either. It had the capability of taking that entire thing and putting it inside of the pressure vessel. It's a hell of a refit, but it can do it. It did that in the early parts of the program. Early parts of the program had the airlock inside of the pressure vessel. You could have configured it for that. It would have been right here, right where, right in this volume right here. See? Look, there's still a hookup for it. The airlock was right here in the early parts of the shuttle program. You could reconfigure it to do that. They took it out and put it in the payload bay so they would have more space. 25 tons isn't much, though. I thought it would have been more. 25,000 kilos? That's 54,000 pounds. Dude, it could put a school bus into space. You could launch it. You could put a light tank in the back of this thing and it could get it into space. I mean, that's pretty good for what it is, dude. In the square hole, that's right. Would it be possible to bring back a piece of the ISS and Starship? Now, Bren, you ask me. Yeah, I think it would be very possible. Do you know what I think? You know what I think SpaceX should do? I think SpaceX should develop a variant of Starship that has a 9-meter version of the shuttle's payload bay inside of it. Now, the shuttle's payload bay is 5 meters. It's a 5-meter variant. It's 15 by 45 feet. So that would be 5 by 15 meters, give or take. Starship should develop a 9-meter variant of said payload bay and copy the space shuttle's payload bay to an extent to fit in the pressurized volume in the front, robotic arm and everything, shuttle style payload bay doors. And then, you know what they should do? Use it to go get orbital debris, old satellites, bring them back down. Use that to test your reusability. Clean up low Earth orbit. Grab old satellites. Grab parts of the space station. Bring down a customer's space station module, like VAST or whatever. There would be a market for that. You know why? Because if you have a cheap way of getting up there and coming back down, that makes going and getting those satellites worth it. Because a lot of satellites use a lot of precious metals, gold, platinum, silver. Just saying, it's a huge market for that. Or just bring them up, or you could just do on orbit, M46, if you wanted to do that. I would contend to say that if SpaceX wants Starship to launch every day, and you're looking at 100 tons into space every day, just build the shuttle payload bay up there. Do exactly, do what the shuttle was supposed to do. The shuttle was supposed to do stuff like this. I think Starship should get a remote control arm. It should get an RMS. You'd be crazy not to do something like that. And then build an adapter inside of Starship's payload bay so you could grab the ISS modules and put them in there. Like have a 9-meter payload bay to 5-meter payload bay adapter. So you build a mini shuttle payload bay inside of Starship's payload bay to accept these modules correctly. I think that's doable. I really don't think that that's as far-fetched of an idea as anybody thinks it is. Semi can carry up to 40 tons. It's impressive. I just thought it would carry more. Yeah, Drunk Al, I'll give you that. That's fair. That's fair, dude. For sure. Yeah, that's fair. But you gotta remember, this thing's a product of the 70s, dude. The shuttle's critical design review passed in 1972, which meaning this is 1972 technology. Think about that for a second. Now, don't get me wrong, the shuttle had upgrades throughout its career, for sure, absolutely. But also, how long would it take to safely decompress the whole station? Decompress, O-Force? I don't know what you mean. Really hope Flight 9 goes better. Looking forward to more progress. Me too, man, me too. How difficult would it be to take off ISS modules? If you had a remote manipulator system, Enzo, easy. I mean, don't get me wrong, guys. Like, I say easy, but easy is a relative term. So the thing about the ISS modules is that they're not just docked to each other. They're wired to each other too. They docked the modules together, and then they did a bunch of EVA operations and ran wires on the outside of these modules to connect different power systems together. The ISS is quite literally, every module is basically conjoined at the hip at this point. That's why nobody's talking about taking these modules back down. Dude, you would be doing unnecessary EVA operations to unplug everything and revert the station to a state that it was in 20 years ago and hope that that electronic technology works. Dangerous. Very dangerous. That's not... I mean, don't get me wrong. I still think I wouldn't be against it. I think it's a good idea, but you know, the astronauts put the damn thing together. They can take it apart. Just saying. But that's a lot more complicated than you might think. I just miss my space shuttle, dude. Talking about it to you guys made me realize how much I still like this damn thing. Also, more space news. Yeah. Oh. Outdoorsman, you're right. I got to do more space news, but also, can you imagine being on orbit and waking up and seeing that with freaking just Earth behind? Dude. Dude, the ambience is awesome. That's so damn cool. That's, would you just look at it? It would have less buttons today. Sims, maybe, maybe not. It really depends. Personally, I don't mind more buttons in space. Buttons are not high mass. Neither are the wires to connect all of them together. I don't mind having manual backups to systems. Software governing the whole thing would probably be the right idea. The shuttle flew a lot like a the shuttle flew a lot more like an airplane. So you had an FMS with the shuttle. You had an FMS and you had 3 phases of the mission. So you had Operation 100 ops, which is launch, 200 ops, which is on orbit, and 300 ops, which is EDL. And you had a flight computer that you program numbers into, just like you would on an airplane. It's a similar thing. It's a similar flight computer. In fact, most airplane flight computers exist because of stuff like that. Yeah. Once again, that's all derived from the Apollo AGC, if you really want to know. Yeah. Kind of advanced the state of the game pretty hard, the Apollo program. Who knew sinking billions of dollars into scientific research and development will yield you trillions of dollars of profit? It's weird. It's weird. It's almost like we should do that. Yeah, toothless. There you go. Depends on how destructive you want to be. If you cut all power and such and just use a docked vehicle station keeping attitude, you could just take bolt cutters to the cables. Yeah, Aqualex, I'd be hoping you're wearing a rubber spacesuit at that point. But yeah, I mean, you don't know what power's like, dude. There's all kinds of different power needs for different systems on it. Like the Japanese experiment module takes a lot of power, so there's probably some high voltage line up there. But yeah, I mean, yeah, dude, just do what a junkyard does when they're pulling an engine. Just cut everything out and send it. That'd be so cool, dude. You know, like, I will say this, dudes. I fully get why we don't want to go grab ISS modules and bring them back down. Even if the shuttle was still flying, I still understand why you wouldn't want to do that. But also, man, we don't do things. NASA doesn't do things because they're easy. Sorry, I know it's frankly quite overused at this point, but you don't do things because they are easy. We do things because they are hard. Like, bro, let's go, man. Why can't you go and get those damn modules? You telling me you can't get those damn modules? What else can't you damn do? Go get the damn thing and bring it back down. Damn. Damn. Just go get it. It's like the Sandlot, man. I can't go over there. There's a giant mutant gorilla dog thing. He's a beast, man. What kind? It already ate a kid once. Is that confirmed? Come here, kid. So just hop over and get it. Just go get it. Do you want me to pickle the beast? Think about that, kid. Remember, there's heroes and there's legends. Heroes get remembered, but legends never die. Follow your heart, kid. Never go wrong. Just go get it. Just go get the stupid module, man. It's right there. It's right there. We have people on it. Just go get it. Ugh. Anyway, next space news. I get it. I know the mission ops would be difficult. I understand. Freaking go get it. Damn, son. Anyway, we got pictures from Lucy. First images from the Lucy mission's asteroid Donald Johnson flyby. Donald Johansson. All right, cool. I was like, Don Johnson, really? Flyby show an elongated contact binary shape with an odd narrow neck between the two lobes. More data from Lucy will be analyzed in the coming weeks. So that's actually super cool. That's two asteroids that were orbiting around each other, and then eventually both of their orbits decayed, and they kind of combined into one thing. So there are some asteroids out there where you get peanut-shaped asteroids. Yeah, pretty cool, huh? You could see where the merging was completed. Yeah, yeah, Acolex, exactly. That happens a lot. Yeah, that happens. Like in The Rock with the guy's leg is switching. What is that? Oh yeah, that happens. Well, I'm having a little bit of trouble focusing here. Do you think there's something you could do about it? What do you want me to do? Kill it again? What you want me to do? Merge the asteroids again? Anyway. Yeah, that's super cool pictures from Lucy. Lucy is an asteroid mapping mission that NASA sent out. Pretty good stuff. Funny enough, in 2018, they planned to give more modules like the US lab and some of the nodes to Axiom. The latter was expected to first dock their main module, the ISS, in 2023. Whoops. 2 years later, first Axiom module slated to launch in 27 and early 28. Looks like ISS docking scrapped, Sag. Yeah, that's what happens when, you try to scale your company without having a lot of revenue. Have we discussed the news from Europa yet? No, but we discussed the news from Uranus. You should see a doctor. If it was possible to mine the asteroids, what do you think about ethical preservation? I'd love to see what usable material it has. Preservation of the asteroid field? Dude, the asteroid field is the leftover byproducts of planets forming in this solar system. It's literally a gigantic junkyard of planetary waste. Go mine the damn thing. Just mine the stupid frickin' thing. Like, seriously, that's all the leftover crumbs from all the planets being made. Any planet that didn't get sucked into a gravitational pull, to make a gigantic planet like Earth, Mercury, Venus, that's the leftovers. Go frickin' mine the damn thing. Preservation. What are you preserving? It's a frickin' rock! Now, don't get me wrong. If you want to mine it correctly, we should probably go and figure out what it is to mine it better. And then doing that at the same time, you kill two birds with one asteroid, right? You learn about what it's made out of. You learn how to mine it correctly. You mine it for resources. And you learn about the origin of the solar system. You can do both of those things pretty easy. That's why geologists exist in an industrial capacity. Because knowing how plate tectonics work really help when you're building a bridge or something. Just saying. That's funnier knowing birds are dinosaurs. Oh, killing two birds with one asteroid. That's a good one. That's a good one. We will save that one for later. They do move in herds, Aqualex. They move like a predator. Just go mine the stupid things. Seriously, just mine them. Dude, there's so many of those. We could preserve 1 million of them, and we would still have trillions of asteroids to mine. Seriously. The asteroid field is huge. It's huge. Axiom is pretty much cooked. They negotiated a new payment plan with SpaceX. They didn't pay for Crew Dragon missions. Yeah, I knew that. Every cent of revenue they get from crewed missions has been used to pay for the XEMU dev and Thales Alenia for the first module. Late 2023, Axiom was a couple weeks from going bankrupt until they got a $350 million funding round from a Saudi PIF. Even with that, the company is barely breathing. Yeah, I know. That's what happens when you decide you're in the space station module business and then decide you're in the extravehicular mobility unit business halfway through. That was a really stupid thing to do, Baron. Please, yeah, destroy anything but Earth. Guys, we're floating around mostly rocks. I'm sorry. This planet is the exception. Okay? Just save this damn planet and go mine the stupid rocks instead of mining rocks here. Right? Like, even if you don't give a frick about preserving this planet, right? Dude, there's going to be a time. Okay, so like, let me put it to you like this. I live in Massachusetts. In Massachusetts, just north, a little ways north of where I live currently, there's Quincy, Massachusetts. Quincy is named after the third president, or the sixth president, John Quincy Adams, right? Quincy used to be a huge mining town. They mined granite. The huge mining town. There used to be pit mines in the middle of the city. Well, not in the middle of the city, but you get the idea. In the hills surrounding the city. We don't mine here anymore. Why? Because there's bigger and better granite deposits elsewhere. This makes no sense to mine here, right? Eventually, we'll get to that point with Earth where it makes no sense having a lithium mine here. When you have an asteroid that's sitting up there with trillions of tons of lithium in it or something, that you don't even need to mine it. You just bring it. You just go chisel a bit off and bring it here. It'll make no sense economically to mine. Down here, that makes no sense. But AJ, that's too hard. That's too hard. It's too hard. Look at this picture. So, ex-user Booster 10 got this picture from Starship Gazer. Oh my god. Oh my god. Are most of the asteroids useless rubble piles? No. They're metal. They're platinum, lithium, aluminum. Well, not aluminum, bauxite technically, but yeah. But that's what the Lucy mission is for. Lucy is an asteroid prospecting mission, believe it or not. Yep, it's studying the Trojan asteroids. So the Trojan asteroids, guys, are a cluster of asteroids that is stuck in a Lagrangian point around Jupiter. It's stuck at the L4 point around Jupiter, if I'm remembering right. Believe it or not, Jupiter, Saturn, and Neptune, the outer gas giants in our solar system, that's what's keeping Earth from literally getting just pummeled by whatever. Because their gravitational pull is so hard, they actually collect asteroids. Yeah, that's what the Trojans are. Super cool stuff. Super interesting. The Psyche mission. Gold, baby. Yep. Yeah, they're both leading and trailing. Exactly. The Trojans are in front and behind Jupiter. They're stuck at Lagrangian points. Lagrangian points are neutral points in gravity between celestial bodies. So, I'll take the Earth and the Moon. There is a point in space, 5/6 of the distance out to the Moon, where the Moon's gravitational pull and Earth's gravitational pull cancel each other out. It's like a gravitational tide pool, so to speak. And stuff gets caught in there. Oh, yeah. Believe it or not, there's one on the far side of the Moon, too. That's where James Webb is. James Webb is actually orbiting in that tide pool. Yeah, it's called EML2. Pretty crazy, right? Also, crew cab. Yeah, good stuff, man. Dude, there's so much stuff out there. If you don't have any idea, we could have all the precious minerals we want. We just got to go and get it. It's just out there. It's just sitting out there. It's just sitting out there. Go freaking get it. Oh. No, but there's a mission operation. Dude, shut up. I know about the mission operation. Go get it. Damn. Sorry, forgive me. I'm getting a little impatient, but also, I like what's going on here. Is that a Dodge? No, that's a dent side Ford that's missing the front clip. It also is an extended cab. So that mid-70s make. Mid-70s extended cab, which is actually kind of rare. Oh yeah, and also there's a Starship hold down right next to it. There's a lot of things going on in this picture that I really, really like. So we just need a lot of Delta V, pretty much. So Sims, that's why SpaceX is opting for an on-orbit refueling architecture for their exploration. Because if you get, dude, a fully fueled Starship in low Earth orbit could go anywhere in the solar system on a reasonable time frame too, which is pretty crazy. What truck is that? Bandit, I think it's a dent side. The slang term for these trucks is dent side because if you look at it from the side profile, it looks like there's a huge dent in it. That's what the accent line is. That could be a 78 or a 79. It's possible. It's an extended cab, so it's definitely late 70s. Ford didn't offer an extended cab until the late 70s, so 77, 78, 79. Jupiter is the gateway and border to the inner planets. This is a simulation done by Brain Truffle of a lot of the asteroid trajectories over time. That's bananas, dude. Super cool. Yeah. And man, old people die, dude. It happens. He's serving his purpose somewhere else, man. All good. We get to see the Pope vent. We have a payload in L2, and while it's an awesome, relatively stable gravitational equilibrium, it's really demanding. You get solar radiation pressure. Yeah, I know. Yeah, I know, Bandit. That's why James Webb, not a lot of people know James Webb has a rudder on it. Yes, a rudder, like on an airplane. Yeah, not a lot of people know that. Seriously. They put a rudder on it, like a sailboat would deal with wind. They use the sail to keep the satellite stable. I'm not kidding. Yeah. Oh, yeah. Dude, I can't believe people don't know this. There's a damn rudder on the back of James Webb. It has a rudder like a ship. Oh, yeah. You put the rudder into the solar winds or away from the solar winds, you can get the satellite to kind of stay pointed in the same direction, just like a sailboat would go back and forth to get to its destination. Anybody that sails knows if you're trying to go that way and the wind's blowing this way, you don't try to sail straight at your destination. You go with the wind and then you turn around and then you do. Dude, James Webb does that. Oh, yeah. It's sick, dude. That satellite is so damn cool. We should build more. We should build like 4 more of those things at least. But what wind in space? Solar wind? That's correct, Ari. Yeah. Galactic cosmic waves, solar wind, bunch of stuff. There's space meteorology is going to be a thing as we go further into space. Oh yeah, that's a big deal. You need space weathermen. In fact, weathermen already monitor space to an extent. Sure. No, my heart can't handle another one. Why? It's more like the shuttle body flap. Close enough. Island, don't worry about that. Don't worry about that. There's no way Congress will allow that to happen, dude. I wouldn't worry too much, dude. Here, look at this Starship hold down point. An awesome dent side truck. That thing is sick. I love it. And it's painted like a highboy, red and white. Very nice. Also, that's a hold down point for Starship. For the second OLM, for OLMB. I hope so. Trust me, man. Believe this random dude on the internet as much as you believe any other random dude on the internet. But also, dude, I'm pretty sure. There's no way. That's not happening. Dude, that would be... There would be repercussions of that. And trust me, I'm pretty sure cooler heads will prevail. Trust me. As much as you could trust some random guy on the internet, okay? Like, pretty sure. Why is it white? Any ideas? It's probably primer, if I had to guess, Nova One. That looks like it's been primered. So it looks like they primed it so it wouldn't rust. White primer, though. You'd put white primer down if you want to put gray paint on it, which is what SpaceX does. But also, I really need that truck in my life, but that truck doesn't have an engine in it. There's no motor in it. But I'd still take it, you know? Why are there two awesome things on that same trailer? I'm not 100% sure why the guy has a dent side and the hold down point. Just because it has no motor right now. Oh, man. Makes me want to work on the freaking Dodge, dude. Damn it. Yeah. That's the thing people don't know. The moon gravitational pull isn't equal. There's a way to make your payload, even as a small sat, to do gravitational surfing. We were talking about that, Baron, when we were talking about rectilinear halo orbits a second ago, man. I kind of wish you were here. You can map your trajectory to raise and lower your orbit. The NRO uses precession. Yeah, exactly. Yeah. Gateway will do that if it ever gets there. He's taking his hold down for a walk. Yeah, HDST. Louvoir is going to be chef's kiss. So I'm a bit confused here. That trailer doesn't seem to be flexing much, so that hold down is relatively lightweight. It's over a wheel, Bright. It's not that the hold down is lightweight, it's that the truck is on the big part of the trailer. They put this over the wheel. They loaded it over the wheel on purpose because that thing is frigging heavy. If you put it here, yeah, you'd get better handling. Like, it'd be more stable going down the road. But, yeah, you'd bow the trailer for sure. That thing is freaking heavy. That hold down point probably weighs 4 or 5 times more than that damn truck. And that's an F-250. Don't ask me why I know it's an F-250, okay? It is. And that's a split axle, so the weight is even further distributed. Yeah, they loaded it up on the wheel. You're making it hard to be quiet about Rule 8 stuff. And you're not helping by posting comments like that. Will you just look at the damn hold down in the truck? Isn't that cool? Isn't that cool? That's a cool truck. Don't you want it? It's a cool truck. Don't you want a hold down point? I want a hold down point. Do I know what I would do with the damn hold down point? No, I'd probably just sit there and say, would you just look at it? But then again, I'd probably do the same thing with the truck. Am I right? Would you look at this? Oh, would you just look at it? That's a Gazer picture too. Starship Gazer took this picture. Be sure to go support them. Gazer's awesome. Good dude. All right. So, speaking of that, we're into the Starship segment. Now it's time for EJ to say, I told you so. Okay? This is the good part. Where are you going? No, come back. I told you so. Think they're going to be back? No? All right, cool. Here, check this out. So, this is from Chrome Kiwi. Chrome Kiwi took a screen cap from one of the NSF cameras and caught that thing right there. That is an OLM attachment plate. That's one of the posts that the OLM is going to sit on.
Discovery.
Also, very nice. See that van? Somebody lives in that van, okay? Spurbury Police! Fluffy, that license plate belongs to a local Spurbury Police vehicle. Down by the river. Yes, of course. Well, ocean, because it's Starbase, but yes. There's also the high bay being disassembled still. Oh, somebody asked me why they cut so many holes in the side of Starbase. Wind. It's so wind doesn't blow the structure over while they're taking it apart. That's why that thing looks like Swiss cheese. Yeah, it's for wind. Yeah, because if you take the roof off of this structure, it's not very strong. The roof is what's kind of tying the whole thing together. Also, quad axle lowboy. There you go. So Chrome Kiwi also got the goods. There you go. OLMB legs. So, here's the I told you so part. That certainly looks like it could be removed. Certainly looks like it could be removed quite easily. Just saying. Are you going to say you're sorry? No? Oh. All right. Well, screw you then. No, these pegs definitely make it look like the OLM plate can be removed. I'm not sure on what frequency that's going to happen because of how heavy the damn thing is, but the way this is all set up from that picture, it very much looks like this can be removed very quickly. It's like a quick disconnect plate almost. But no crawler, so we still win. I don't... No. You sure it's an F-250? Credit to Starship Gazer. Yeah, of course it's an F-250, dude. Oh, you got another picture of it. It is an extended cab. All right. Absolutely 100% an F-250. Yeah. Dude, you're questioning my Ford truck knowledge? What are you, crazy? Okay. For the noobs, dead giveaway. 8-lug rims. Okay? 8-lug rims. So, to be 100% fair, it could be an F-350 as well. It's possible. It's possible it could be an F-350. But F-350s tend to have heavier duty suspension. The ride height would be a little bit taller if it was a 350. And if it was a 450, it would have 10-lug rims instead. Dead giveaway. That's the easiest way to tell the difference between old Ford trucks. 5 lug nuts, F-150 or an F-100. 8 lug nuts, F-250 or 350. 10 lug nuts, 450 and up. Why are you looking at me like I'm nuts? So that's also a 4x4, by the way. It's a 4x4, and it looks like it has twin traction bars, which is pretty cool. Long radius arm. See that right there? See that big metal piece that goes to the front axle? That's an increased radius arm. So a long length radius arm, telling me that this is a 78 or a 79. Yes, I know a lot about this because I'm a loser. I get it. I like old stuff. What do you want? Do those wheels stay on with all those nuts? Got them. Well, it turns out if you tighten them, yeah, yes it does. If you don't, well, it's got front locking diffs, Outdoorsman, yeah. That's a Sterling rear end. That's a Sterling 1025 out back, and probably, so it has twin traction beams, so TTB, so it's a Dana 50 in the front. And if you think I'm full of crap, look, here, I'll show you. So twin traction bars is an independent front suspension that Ford put in trucks from the early 1960s, basically until the 90s. It's that. That's a Dana 50 TTB. The center section of the diff is on the lower control arm. Yeah. And then the drive shaft has a CV joint that connects to the other lower control arm. And it's on leaf springs. Independent front suspension. With drive. Pretty cool, huh? I know it's a TTB. I know it's TTB because that other picture, the truck obviously doesn't have an engine in it. It's riding high in the front and the wheels were cambered out. Yeah. See the front wheel? They were up like this. TTB. TTB has a huge length of travel. And when they're in the upright position, the TTBs unload and the wheels camber out. Yep. Super cool piece of kit for the 60s. By the time the 90s rolled around, it kind of was not the best idea. My truck has the 2-wheel drive version of this, so there's no center section. The downside of this is that you have a lot of what's called unsprung weight on the axle, which makes handling not great. But then again, it's a truck, so who cares? Basically, the more stuff you have before the spring, yeah, the crappier it handles. It doesn't handle very well because the spring has to deal with the weight of all that crap moving around. Yeah, there you go. There's your truck derail for the day. Also, that hold down point is frigging gigantic. It's a really nice truck. Yeah. Super clean, no rust. I wonder where that thing's going to end up. Bandwagon is soon. That's right. That looks so weird. I'm used to seeing symmetrical all-wheel drive systems. Yeah, it's a little bit of a trip, Galaxy. Yeah. How'd you like we could throw a Dana 50. I could put a 50 TTB in the 97. It would bolt in, believe it or not, because the difference between twin I-beam and twin traction bars is one has a diff in it. You could put those in the truck if you want. That'd be kind of cool. I want to convert the 97 to four-wheel drive, but that's after we finish working on the Coronet job. So check this out. Guys, we definitely got pins. They're definitely going to put this on some type of pedestal. That really very much looks like it could be removed quickly, but I'm not sure how. I still haven't honestly figured out how the heck they're going to get that OLM to pad B and lift it up and put it on this. I don't know how you're going to do that. To be 100% honest with you, that OLM is huge. It's the size of like a mid-sized house, and it probably weighs way more than that. Dude, that OLM's bigger than my garage, and my garage is not small. Do you know if they plan to use a similar design for the Gigabay as they did for the Megabays? The Gigabay is, okay, Vert, I can show you real quick. So, if the Megabay looks like this, right? And then you have spots here, 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 and here, and obviously here for starships. That's the Megabay. The Gigabays are going to look like this. That's what the Gigabays are going to look like. Way, way, way bigger. A Megabay is about this big. It's like 3 Megabays stacked back to back, too deep. How's that, huh? It's going to be freaking gigantic, dude. It's going to be a monster building. Like you when they build the Gigabay in Florida, it will be noticeable. It's not as big as the VAB. It's about 2/3 the size. It's big. It is a big building. Yeah, and it's going to be way taller. The Gigabay is probably going to be another, like if you chopped a Megabay in half and stacked it on top of another Megabay, so you had 1.5 Megabays tall here, any unit but the metric system, boys. That's how tall the Gigabay is. Sorry. Hey, I painted a good picture in your mind, okay? Yeah, Vert. It's not going to be similar, no. The Gigabay won't have the beams sticking out the sides, dude. Those are called... Chat's gonna get me. They're called flying buttresses. The Gigabay will not have that. Well, at least I'm pretty sure it won't. One, because SpaceX renders don't have all those bars sticking out. And two, when you're building a structure that big and that wide, you can't rely on a flying buttress to hold the thing together. You need to have some internal structure. So it's going to be built similar to the VAB with an internal truss structure. Yeah. Yeah. It'll end up, from the inside, it'll look like the VAB. From the outside, it'll look flat, like the VAB. Yeah. Does that make sense, dude? And here's another shot from Gazer of the dang leg. Man, that thing is beefy. You said butt. You said butt. Buttress. Use the Ryan Caden image from the Space Coast flyover. I have to go find it, dude. Haha. But. Right, yeah, that's the kind of stuff I was wondering about. Not too familiar with structural engineering to that scale. Yeah, you can't use external support. Bits! I like big buttresses, and I cannot lie. Okay. Anyway, when you're building that big, you're going to need to have an internal structure. The reason why SpaceX used the flying buttresses for the Mega Bay is so they wouldn't have to use an internal structure. If you notice, the inside of those bays are hollow. There's nothing there. There's no like internal structure except at the very top where the gantry crane is, and that's tied into the sides, right? With what SpaceX wants to do with the gigabays, you can't do that. Well, you could, but it would be easier to just build an internal truss structure. I have a theory, dude. If we want to open up Paint one more time, I have a theory that say this is our proverbial gigabay, right? You know, here's door number 1, here's door number 2, door number 3, door number 4. Obviously, you're going to have a huge truss structure right here to kind of hold everything together, and then you're going to have truss structures on the sides, right? And then up top, you're going to have, so like right here is the tracks for the gantry cranes, right? And then on the other side, you're going to have the same thing, right? And then your gantry cranes are going to be able to be here and here, and they could traverse both of the aisles, right? If SpaceX was smart, and I think they are, what I would do is have a side door right here. A side structure for getting your sub-assemblies in. Right? Because we know Star Factory is right here in this design. And the Mega Bay 2 is right here. Or Mega Bay 1 is right there. You know that Star Factory is right here. There's going to need to be some type of internal door. Or some type of structures on the back, right? That tie into the Star Factory. Stuff is going to need to come in this way, and it's going to need to come in that way. Because think about SpaceX in like production lines. So now we're playing Factorio here for a second, okay? Is SpaceX really going to have the nose cone production line go all the way over here, all the way around, and all the way back? No. Why would you do that? No. The components that are going to probably come in through the back door are common components, like rings, right? Think about it from an assembly line point of view. The stainless rings, they're common between Super Heavy and Starship. Those are going to come in this way. Specialized components like engine sections for Super Heavy, transfer tubes, Starship engine section, Starship nose cone, bulkheads, those will come in through the sides. And if that's the case, what SpaceX will most likely do is at a lower level have a transfer aisle right here, just like the VAB, and then have a gantry crane that's bridged into the Star Factory, right? That can move back and forth. So at the end of the production line, you drop it here, the gantry crane comes here, picks it up, it can set it down right here, and then your bigger gantry cranes that are up here can pick it up and move it to whatever processing stool or processing station you need to put it at. See what I'm talking about? I would put rings down here, have rings go through there. Engine sections, maybe, right? And then but your nose cone assembly isn't going to go all the way around and all the way back here. No. You'd have it go right to its component right here. So Starship nose cone assembly integration jigs, right? Which would be the last thing that they put on with flaps before it rolls out to Highway 4. Does that make sense, dudes? It's basically a little mini VAB. The VAB is set up like that. Inside of NASA's VAB, there's a center transfer aisle, and then there's 4 high bays on either side. The idea is that you roll in stages, and then they can go to the 2 forward high bays or the 2 back high bays. That's the whole idea. NASA still does that to an extent, but it's a cheap, watered-down version of it that utilizes 1 high bay instead of 4. But you get the idea. Well, technically 3 out of 4. High Bay 1 has been abandoned since the end of the shuttle program because I don't know. Maybe I'll 3D model it for you guys someday. Maybe we'll do it. Maybe I'll show you what I'm thinking. But yeah, what other parts do we have? This is another shot from Gazer. There's the back of the truck right there. So that's a hold down point. That's a new hold down point for Starship. It's a little bit beefier than the previous design. Yeah, hold down clamp. Oh my goodness, that's way beefier. I think a pass-through crane would be too much of a bottleneck. Yeah, Geeson, the horizontal crane is just a theory. SpaceX will probably just put doors on the side. Just have a transfer aisle. You don't, maybe not necessarily having that horizontal crane, but just the transfer aisle so the big gantry cranes up top in each aisle can pick up stuff and stack. That's my guess. It's one or the other. I mean, either way, they're going to be feeding a gigabay from the side and from the back. You know what I mean? You're not going to send all your components just to the back of the gigabay and stage them back there. That makes no sense, right? Would it move propane and propane accessories, boy? Yes, you're dang right it would, buddy. Dang it, Bobby. The structure would require to support multiple multi-hundred-ton gantry cranes. Yeah, that's what I mean. The internal structure is going to be needed for that. Speaking of crazy big structures, this is a picture from RGV over the weekend. Take a look. The diverters are in place. Or the flame buckets are in place. Damn, dude. The amount of progress that's being made on this dang structure is frankly ridiculous. How do we know the gigabay is rotated that way? You know what, Hoth? I guess I don't. I have no way to prove that. The gigabay could be pointing towards Remedios, and then my theory's out the door. I think it's going to be the doors are going to be pointed towards Highway 4, I think. I don't know. Call it a hunch. I don't have any concrete evidence to say otherwise. They could point them towards Remedios. The problem is there's a parking garage in the way. You know? I mean, it's just process of elimination, dude. Like here, let me go to Google Earth real quick. That's actually a super good question. Like here, let me think about it. So we're going all the way down New Brownsville. When will the other two bays be taken down? Eggy, I'm not sure they're going to, dude. So, dudes, the Gigabay, so the parking garage is right there, facing towards Remedios, right? So the Gigabay is going to be right here, from what I understand. Like, it's going to be here. So, Hoth, the thing is, this doesn't really give you any other areas to push them out. So that tells me that they're going to have their two transfer aisles right here because, once again, you're right up against that parking garage. And I don't think SpaceX is going to get rid of that parking garage that they just painted that nice new mural on. I mean, they might. Who knows? Just go out on Joanna Street? It's possible. But the other thing is, guys, if you look at Star Factory, look. You could see the tracks for the overhead cranes, right? These processing stations, their production. Think of these, each one of these as a conveyor belt, right? The nose cone conveyor belt went down here and then they turned the nose cone belt. They're not going to do that. They've demolished this triangular structure. Believe it or not, they're actually getting rid of it. And it's going to go this way. I think it's going to go right into the bay. There's going to be two aisles right here. And I guarantee you they're going to be feeding rings from the back. Why? Because it's a standardized part. Both of these aisles, say you're building super heavies over here and you're building starships over here. Why would I think they're going to build starships over here? It's next to nose cone processing. I'm pretty sure they would have, thought about that, right? So I think this bay right here is going to, where the ring yard is, right? Is going to be for starships. And then over here is going to be for super heavy, right? So that tells me that, nose cones wouldn't go all the way to the back of the Starship assembly line, right? Engine sections would be first, and then barrel segments, then common domes, right? So they'd be making SN5s in this part of the thing, right? And then the payload bay volume area, and then nose cones would be last, which is basically what we're seeing with Star Factory. The nose cones are front and center. If you've been down here, you can look in and you can see that they're making nose cones in this aisle right here. One, because it's taller and it can fit the entire subassembly in, right? We shall find his age, cut him in half, and count his rings. Forrest. Good episode, man. How do you think Starship will come down back to Boca the next couple of flights? How do I think it'll come down? I hope it'll come down good. It didn't come down good last time, or the time before. Oh, trajectory-wise. It's coming from due east. Or due west, excuse me. It depends on the insertion azimuth, Sea Kraken. They're launching with an azimuth. They're not necessarily launching with a 90-degree flight azimuth. Well, actually, no. Sorry, I didn't say that right. The past Starship flights look to be launching with a 90-degree flight azimuth, okay? So, you launch with a 90-degree flight azimuth. Boca Chica is 27 degrees north. So you're going to... Or no, not 27. It's less than that. Shut up. 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 You think they'll fill those gaps in the flame bucket? Yeah. Those are probably there just for installation, Jack, so they could secure another component before they put the last pipe in. It's 26. Okay. So I was close. It's 26 degrees north. So if you launched straight east out of here, right? Your orbit's going to look like that, basically. Actually, it would look pretty much like that. Right? So that means basically, if it's coming around, dude, you're basically going to come in from this way. People think it's going to come in like that. No, I don't think so. I think trajectory-wise, it's going to come in like this. It's going to come in from straight east. But that's going to look a little bit... That track, that ground track superimposed would look something like this. Nah. Give me 2 minutes. No. Once again, it depends on the flight azimuth of your ascent, of your uphill ride. It absolutely depends on it. And anybody's like, no, give me a second. No, you're wrong. It's the flight azimuth. Unless they're changing their orbit or doing some type of on-orbit plane change. No, that's what the trajectory is going to look like. How much control does Starship have with its approach trajectory with those flaps? A lot. Not as much as the space shuttle, but it has cross range. Oh yeah, it could do it. Overflying land. Shuttle did it. Do you think it would overshoot and come back from the east? What are you talking about? So... You're talking about, like, flying somewhere, like, out here, and then belly flopping and coming back down? Like that? Yes. Yes, I do. I think it'll absolutely do that. Yeah. I don't think it'll be 10 miles out, dude. No, I don't think it'll be 10 miles out. Once again, you don't have the cross-range capability that... You don't have cross-range like the space shuttle. This thing will basically stall out right... If I'm looking at this right, the thing will stall out and enter the main belly flop, like right here. I mean, keep in mind they could do this from a different direction. They could do it. I think they'll probably end up, like, looking at this now, they'll probably end up doing something like this. Like, and guys, keep in mind, this is a super steep trajectory. You're probably losing 100,000 feet from here to there. This is a belly flop, and Starship basically doing this when it belly flops down. Yeah, I would circle out here because there's nothing out there. I would not go this way because then you fly over Port Isabel and South Padre. I would not do that. Page 154. Good number. Heading 22 to 158. So if you're going to do this, nah, dude, they're going to do a plane change over the Indian Ocean. Okay. Yeah, so if they were going to do a plane change over the Indian Ocean, that's what it would look like. Yes. Remember what I said about insertion azimuth or an on-orbit plane change. That would change the trajectory because that is not a 26-degree inclined orbit. Absolutely not. That's like a 50-degree inclined orbit, which means you're going to see one hell of an on-orbit plane change at apogee. Hey, Serenity Vox, 41-month resub. Thank you. PC Trojan had a 75-monther in there, too. Thank you. How much cross range does Starship actually have? Mason, it's not going to be a lot.
Oh, this is space. I'm in space.
Serenity gifted a sub to Paw Angel. Paw Angel, excuse me. I put it all together. Thank you. But yeah, okay, so this is an on-orbit plane change. If they just launched on a straight eastward trajectory at 26 degrees inclined, which they have to because they don't want to fly over Florida, at least initially, right? The trajectory coming back would go this way. But since they're doing that on-orbit plane change, they're going to come back from a big inclination. Also, when free, check the size of the sonic boom. Yeah, you'll hear it all the way in Harlingen. Deploy the shuttle and turn on entry. Yeah, not as much as the space shuttle, dude. Not as much. Starship's shape. What's the right way to explain this? Starship's shape will not give it as much cross-range capability, all right? Because the reason why is because Starship's shape is designed to keep the bow shock as far away from the vehicle as possible. Now, here, let me get the model out. When Starship re-enters, guys, it's not going to be re-entering like this. I mean, it will to an extent, right? It's not going to be re-entering like the space shuttle, like you'd think. It's going to be re-entering like this, okay? And I'm sure there'll be angle of attack changes here and there. Modulating angle of attack is how you get cross-range capability in the first place. Doesn't matter if it's a capsule or the shuttle. Shuttle would just nose up and nose down. A capsule would roll to change the angle of attack, right? Now, Starship probably is going to come in at certain points like this or like this, but primarily you want it like this. The reason why is because this way, basically, if you're looking at it from the front, it's a sphere or a circle. And if your oncoming, it looks so sad with the flaps down. If your oncoming reentry is coming at you this way, your bow shock's going to look like this. So where the plasma is. With this type of shape, with reentry coming at it, your plasma is far away. It'll stay far away, so it won't get as hot. But you're sacrificing cross-range capability for that. Now, don't get me wrong, Starship could tip the nose in. Sure. They could tip the nose in a little bit, and you could get some cross-range capability here. But the more you tip that nose in, the more your plasma is going to get closer to the nose cone. So out here, say your bow shock would be up here somewhere. The more you tilt it in, the closer it's going to get. Which is why on Ship 29, we saw it burn through. They had it tilted, right? Remember they said they were going to kind of go back? They were going to kind of go backwards a little bit. I mean, that was basically during landing, but you get the idea. They're going to do this. Because you'll get a lot of burn through up here. That is the other reason why they moved the flaps to up here. The flaps aren't here at like the 3 and the 9 o'clock positions. They moved them on the Block 2 ship. They moved them up here to get them out of the flow. So when Starship moves forward, if it noses in like this, you're not going to roast your flaps. That's the reason why they did that. Does that make sense? Interesting. That's right, Tron. You heard it here first. So, Baron, look, it belly flops, dude. That's doing exactly what I think it's doing. Starship is going to get up over the tower. So, like, if the tower's here, Starship's going to get up there at, like, 20 kilometers and belly flop down onto Starbase. Which is why I don't think it's going to fly out over the ocean very far. It's just going to stay up high as long as it can until it enters the belly flop, right? And you'll modulate the flaps to get it out in front of the tower, and then it'll come back in backwards. It'll belly flop and do the flip and burn out over water, right? And then it'll come in and get grabbed by the chopsticks. Holy crap, that's going to be insane. Dude, that's going to be nuts. It's going to be absolutely ridiculous. Yeah, it's going to have to, Shaw. How is it going to... Starship has its leeward side facing towards the tower. So if your tower chopsticks are this way, right? If your tower chopsticks are this way, Starship isn't going to come in and land like this. No, it has to land like that to get the catch pins. I mean, I suppose you could get it the other way, right? I suppose you could land it like that if you really wanted to. Maybe it'd be good for a first test, right? But how are you going to reattach your umbilical? How are you going to safe the tanks? How are you going to do any of that? It has to land backwards into the chopsticks. So like if your tower is facing this way, say I'm facing east, Starship is going to come from the west, right? And it's going to belly flop and it's going to have to go out over the water and then come back in and get caught, right? Like, am I thinking about this wrong? I'm pretty sure that's right. I wonder how the sonic boom will be. Loud. Very loud. There's your sonic boom propagation there from the environmental report. I'll link this up for if you guys want to see it. That sounds right-ish. This will be weird when it gets normal. But it's not going to... See, like, it's not going to look like Starship is flying around and coming in and landing. It's going to look... You know what it's going to look like? Hold on. It's going to look like SN15, dudes. Let's just get to the good part.
And we have ignition.
That's what, see, the tower is going to be basically right where my mouse cursor is.
Starship heading back to the landing zone.
Chopsticks will close right now. And that's it. But do you see how it's kind of like this? It's kind of like tilted backwards a little bit. Because it's going to swing itself into the tower almost.
Heading back to the... And we have ignition.
See that? See how it's coming in kind of tilted with the butt facing out towards the ocean? That's what I'm talking about, man. It's going to basically swing itself right into the chopsticks. It's going to look weird at first, but after, dude, I'm telling you, the first time they do it, it's going to be like, wow, why didn't we do this? Why haven't we done this before? Just like Super Heavy was, man. The first time I saw Flight 5, we saw Flight 5. First, we saw Booster 12 get caught. We saw it right here on the stream, right? First time I saw it, I mean, it blew my freaking mind. That reaction video is still hilarious. But I was just like, that looks normal. That looks like something we should have been doing a long time ago. Like, I didn't think it would look like that, but I'm just like, oh, yeah. Yeah, of course. Why? Yeah, of course it does that. Why wouldn't it? Right? I don't know about you guys. Yeah, Jack, you could do a 180. I mean, if you wanted to introduce more control rates into your algorithm, sure. Yeah, you could do that. I'm saying that's more complicated. It's a more complicated maneuver, but it could do it, sure. Replay Flight 6 at 102.25 and go from there. The ship demonstrated turning capability at supersonic regime. I think she's going to overfly the launch site a bit, turn, then land. Yeah, that's what I'm saying. It's going to go... So, Baron, it's going to go out here. It's going to go out here. Not too far, but like out here just in case... Like, remember Falcon 9s back in the day? The RTLS? They had the RTLS... They set the trajectory over water in case there's a divert. Right? So if something goes wrong, it'll just plunge into the ocean instead of damaging the pad or anything. Starship's going to do the same thing, at least initially, right? And it'll do an offshore divert. So it's going to go out over the water, but it ain't going to go very far.
Starship heading back to the landing zone.
Oh, dude, that's going to be so sick. When that thing gets caught, oh my goodness. That is going to be the gnarliest thing I think I've ever seen. It would probably aim for the same ditch that Super Heavy does. Pretty much. That Flight 6 footage is such a treat. Yep. Dude, yeah. Here, hold up. Let's load it. We'll load it up.
Is at 100 kilometers altitude.
I want to see this again so bad, dude.
Starship has started the subsonic belly flop.
What the actual hell? You gotta be shitting me. Sorry, Thomas. So, dude. I'm telling you, first time this gets caught, it's gonna look right as rain, man. It's gonna look like that. Oh yeah, of course it's supposed to do that. Why wouldn't it? I still can't believe this footage exists. Dude, that's precise enough to get... That's precise enough for the tower. It absolutely is precise enough for the tower. The DCS side translation flip and land blew my mind back in the day, but this is on another level. It's crazy, dude. It's, yeah, that's, yeah, it's as big as a shuttle external tank. Actually, it's bigger, but, yeah.
Starship has started the subsonic belly flop. Starship has landed.
What the hell? The G-forces will need to be figured out. Cirrus, I don't think that you're going to pull as many Gs on this as you think. It's just because of the point of rotation. It won't... Like, if you look where the people are going to be, they're going to be right here. That point actually doesn't rotate too much. Obviously, I know the ship flips, right? But it's not like you're going to be, like, thrown around and you're going to get, like, an acceleration. It's just going to be like, think seat rotation in Dragon. I mean, a little tougher than that. But I don't think that that's an insurmountable, like, thing. Do you? I really don't. Like, the point where people are is not rotating very much because it's toward the front, because the flaps are moving your center of pressure up forward, right?
Starship has landed.
Dude. That freaking thing, man. That thing's just on another level. Yeah, we talked about that already, Baron. He's fine. It's just the Soyuz landing's a little rough, and he's 70 years old. Okay, we still have more Starship updates if you guys want. We got a couple minutes until bandwagon here. That's correct, Erudite, yes. Are you gonna plan to jump? Are you planning to jump on the bandwagon? Did it already start? Is the cast already going? Oh, it did just start. What's after hours tonight? I don't know. We'll see. Yeah, I can agree, but it needs lots of testing to put humans on before even close to landing that thing. Well, of course, dude. Yeah, never said it wouldn't. It's gonna take some time to dial that in. You ain't lying. That ain't no lie. Guys, I think we'll end with the rocket launch, dudes. I wanted to do some after hours today, but I also have some other stuff to do. Yeah. Let's did you check the V3 booster article? No. Also, you guys want to see something interesting? Check this out. This is the 39A chopsticks at the Cape. SpaceX is full steam ahead on working on those things.
Discovery, go at throttle up.
Which is pretty bananas to me. Dark Silver Space, press the button, make it go up. It's a V3 booster? Oh, this thing. The test tank aft, fan name TT-17, but it's a next-gen booster testing article that is making appearance at the production site. Ooh, fancy. No more cowbell. Why is the red giving you early Apollo vibes? I don't know, but I like it, Outdoorsman. They're half the length, Mr. Bond. Yeah, dude. Look, the no more cowbell vents. They're integrated. The boys on Discord zoomed in. It's a V3. Yep, right there. It's a test booster. Spoiled. That's not a vent? What do you think it is, a vent, dudes? Those are not vents. Well, what is it then? It's a little short for the booster. It's a little short for a stormtrooper. This is the test header tank you saw roll out. I'm confused, Event. What are these? I know that this is a test article. I asked you what these are, and you said what the whole thing is. What is this? What are those two things? The nostrils that are on there. What are those? Those are the pipes that came off the top. It's for the struts at the test stand to go in to apply stress on. Oh. Interdasting. Cool. They're access panels. Yeah. I seem to have that. It's holes that will be attached to the header tank. And oh, I get it. Yeah. Hold on. No, not that. Yes.
Discovery, go and drop up.
Okay. Interesting. That's interesting that they want to put load on it right there. Huh. Hey, Aaron, thank you for the super chat. Appreciate it. Curious. Huh. All right. Anyway, let's cap off this space news with the Bandwagon 3 mission. Shall we? Let's shall.
Payload Korea ADD's 425 Sat-3. Also on board is Tomorrow Company Inc.'s Tomorrow 57 and Atmos Space Cargo's Phoenix re-entry capsule.
Cool.
Now our bandwagon missions launch to a mid-inclination orbit, differing from our transporter rideshare missions, which launch to a sun-synchronous orbit. The mid-inclination orbit fills in the gaps for our customers that want to expand their coverage or complete unique mission objectives, because changing the inclination of an orbit changes the way a satellite moves around the Earth. Mid-inclinations offer a higher revisit rate, meaning that satellites in this orbit fly over the same point on Earth faster than they would in some other orbits.
Rideshare missions significantly increase access to space for small satellite operators around the world, and we're committed to continuing these launch opportunities for our customers. To date, SpaceX has launched 1,130 small sats for more than 130 customers across our entire rideshare program. To learn more about the program, visit spacex.com/rideshare.
Okay. All right. So this is the Bandwagon 3 mission. We got Booster 1090 flying tonight on its third flight. This is an RTLS mission. It is going to land at Landing Zone 2. So that booster is going to turn back around and land. This is the third flight for this booster. This is launching from Pad 40 out at Cape Canaveral Space Force Station. This is SpaceX's 46th launch of this year.
Conditions, and the range is ready to support. If for some reason we don't launch today,
Thanks,
we do
William.
have a backup opportunity tomorrow at 8:26 p.m. Eastern.
Yeah,
And
spoiled.
one
That'd be
final
pretty
note,
cool.
at our customer's request, we'll be ending our webcast a little bit earlier than usual today, and we'll be wrapping up just after the landing of the Falcon 9 first stage. So with that, let's take a look at one of the bandwagon payloads we'll be sending to orbit today, Tomorrow 57, on behalf of Tomorrow Companies.
The impact of what we're doing at Tomorrow is once in a lifetime.
Oh, serious, don't give me that bull crap, man. Come on. This is not the same thing. Double standard! No.
Have access to the same data.
It's still cringe, dude. It's still, I don't care who does it, it's still cringe.
Is hourly coverage enough, or do we need to go down to 30 minutes or better?
We're seeing heavier rainfall. We're seeing stronger hurricanes and tornadoes and all types of storms, and we're seeing them more frequently. So the economy is basically begging for data, begging to have better weather forecasts so they know literally what's coming.
People cannot, businesses cannot just consume models out of the gate. They need a product, a platform that can help them make decisions at scale so they can become more resilient. That's the goal.
Tomorrow.io had essentially decided that microwave sounders is going to be where they're going to focus on.
With our constellation, once it's fully in place, you can see there's hardly any gaps left.
Devoting your life to building hardware that goes to space is a bit of insanity because you spend a lot of time, and then there's this one moment where whatever you build gets launched and it either works or it doesn't.
2, 1, ignition.
And I have seen something go from hardware in a pile to being launched in a year and a half.
You get the first scan from space and it looks beautiful.
All right, I get it. If the Raptor 3 won't have the heat shroud on it, how will the propellant run into it during reentry to keep it cold? It's inside of the engine section, so it's not going to be exposed directly to plasma, Trapo. I mean, it's still going to get hot back there, but it should be enough to bleed the engine and not worry about it. Roll ads to prevent the pre-roll? Yeah, that's a good idea. Guys, I always roll ads before these things fly on the Twitch side of things, so you don't get an ad in the middle of ascent. So, yeah, we're going to roll them now. Tell me when they're over. I hate ads for what it's worth, but... Hey, Twin Screw. Missed you, bro. Oh, yeah, hey. Where have you been? Yeah, Twin Screw, you over on Twitch, you had a 1 where the I should be in your name, right?
Today, we came together as a team and to create something unique and hopefully life-changing for many, and enable Europe to do a giant leap ahead.
Nice memory. Still got it, bro.
One of the biggest
Still got it.
challenges in the space industry today is to return spacecraft or cargo from space.
Honestly, this B-roll music is probably going to mute the VOD, so I'm just going to not have it. What? You're going to do... What? Really? Huh. That's... Man, I really wish I could hear what they were talking about, but, you know, this is good, too. Done with the ads. Thanks, Wooly. What's the mission? This is the Bandwagon 3 mission. It's a rideshare mission going to 45 degree inclined. One of the missions is a re-entry vehicle. And if I saw that right, the re-entry vehicle has a ducted fan built into the heat shield for descent and landing? Question? All right, I cannot.
If there's one team that can make it happen, it's probably this one.
Atmos.
Discovery, go at throttle up.
Interesting.
Currently awaiting liftoff of Falcon 9.
Yeah, Bright, did you see that?
Over 5 minutes and 45 seconds. While the countdown continues, let's meet SpaceX's Falcon 9 rocket. Falcon 9 is a two-stage rocket designed for the reliable and safe transport
45
of
north, Dan,
satellites,
yep.
cargo, and people to outer space.
Located at the very top of the rocket is the payload fairing. The fairing is a protective shell that houses all of the spacecraft, shielding them from aerodynamic heating and mechanical stress until the vehicle is outside of the Earth's atmosphere. Now, the aerodynamic shape of the fairing also contributes to Falcon 9's...
Yeah, that's right, Aerodynamic. Yeah, CRS-32 launched this morning and landed on LZ-1. Yeah. There was a Dragon resupply that went up this morning, too. I fell asleep.
And fall back to Earth, where they are recovered by SpaceX to be refurbished and reused on future flights.
Falcon 9 tanks are pressing for the start of strongback retract.
There you heard confirmation, preparing for strongback retract. So
games.
this evening, one of the fairing halves will be flying for its 15th time, and the other will be flying for its second time.
And right below the fairing, we have our second stage, which houses our single Merlin vacuum engine, or MVAC engine, which will take our payloads to their drop-off point.
Yeah, that's
now,
definitely
below the
funky,
second stage
dude.
is the black carbon fiber inner stage, where the MVAC engine...
retract has started.
Discovery,
and good
go
call
at
out there
throttle
for
up.
strongback retract.
21-month resub.
Now, below the second stage is the black carbon fiber inner stage, where the MVAC engine is located. The inner stage connects the two stages and houses the center pusher that allows the first and second stages to separate during flight.
Moving down the vehicle, below the interstage, we have the first stage, which we tend to refer to as the booster. The first stage makes up the bottom two-thirds of the vehicle and is equipped with 9 Merlin 1D or M1D engines at the base. Those 9 Merlin engines do the bulk of the work to get the rocket off the ground and up to the thinner parts of Earth's atmosphere.
This is Slick
generating
40?
more than 1.7
Down at the Cape, Charles.
million pounds of thrust.
John didn't retire.
Now, at about 2.5 minutes into flight, the first stage will separate and make its way back to Earth, attempting a land-based landing at LZ-2, not too far from the actual launch pad.
He called the
And
FREM2
tonight's
launch
mission
on
is
this.
the third flight for this booster. And if successful, this landing will mark SpaceX's 435th landing of an orbital-class rocket.
Okay. Strongback is retracting.
Now at T-minus 3 minutes and about 15 seconds, all systems continue to be go for an on-time liftoff. At liftoff, the transporter erector, or TE, will retract away from the vehicle to clear the way for Falcon 9's ascent, which you have seen some great views of on screen.
Are those new clamp arms, dudes?
Now, at this point in the countdown, both the first and second stages are nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. Falcon 9 uses two propellants, a refined form of kerosene called RP-1, or Rocket Propellant 1, as the
Yeah,
fuel,
they look clean.
and
That's what I'm
LOX,
saying,
or
David.
liquid oxygen, as an oxidizer.
Now, at the T-minus 60-second mark, Falcon 9 will be in startup, and this means the rocket's autonomous internal flight computers will have taken over the launch countdown. And just inside of T-minus 2 seconds, we'll light the M1D engines for liftoff.
Stage 1 launch load is complete.
Discovery, go at throttle up.
Command Racer, what's up, dude? 8-month resub. You're just in time.
Now, the Bandwagon 3 payloads continue to be healthy, and at this time, the Falcon 9 team is tracking no issues on the rocket. Currently, weather is green, and range is ready to support a T0 of 8:48 p.m. Eastern Time.
Okay, T-minus
Now,
2.
if stage 2 LOX load is complete.
I was just about to say,
And
stage
good
2
call out there
LOX
for
loading
stage 2
should be
LOX loading
complete.
completion. Now, if for some reason we...
You're going to get a ground gas closeout here, a big cloud of condensation. Gaseous oxygen will be coming out of the transporter erector. They're evacuating the propellants out of the gray structure on the side because that has the fuel and oxidizer lines that go to the second stage. You do not want rocket fuel inside of your launch pad when you go to launch. Your launch pad could rocket fuel itself. Yeah, you don't want that. So they're evacuating the gaseous oxygen out of the system right there. They're purging it out with nitrogen. They're pumping gaseous nitrogen out of there, and it's displacing all the gaseous oxygen. That's what all that stuff is going on up there. Falcon 9 will go into startup here in about 20 seconds.
Internal flight computers will have taken over the launch countdown.
Run the
and then
monkeys.
just inside of T-minus 2 seconds, Falcon 9 will light the M1D engines for liftoff.
Oh, nice, Baron. That's cool.
Falcon 9 is in startup.
Okay, there we go. There's the startup call.
Now with that confirmation, and next up, the launch director will give their final poll for launch, so let's listen in.
Launch director should report go here in a moment.
Launch director, go for launch.
Told you.
And at T-minus 40 seconds, all systems are go for Falcon 9's launch of Bandwagon 3. So let's listen in to the final countdown.
Chat is go. T-minus 30 seconds.
T-minus 30 seconds.
Just said that. $20.
T-minus 15 seconds. T-minus 10.
Pad deluge system
9,
is on.
8, 7.
Sound suppression
6,
water system is active.
5, 4, 3, 2,
Ignition.
1. Ignition. Engines full power and lift off. Go Falcon, go Bandwagon 3.
Stage 1 propulsion is nominal.
Bandwagon 3 is out of the hole and into the air.
Downrange.
The 30-minute inclination rideshare mission for SpaceX. Coming out of Slick 40. Should get a call here for power and telemetry in the next 20 seconds.
Now at the T-plus 32 second moment, Falcon 9 has lifted off from Space Launch Complex 40 at Cape Canaveral Space Force Station. We are currently throttling down to prepare for max Q, the point of maximum aerodynamic stresses.
Power and telemetry nominal.
There it is.
On the vehicle, good call out there for power and telem nominal. You can monitor the vehicle's telemetry in the lower left-hand corner of your screen.
Vehicle is supersonic.
Yeah, booms. It'd be low on the horizon for us up in the northeast, pal. 45-degree inclined. It's kind of halfway. Maximum dynamic pressure is kind of halfway between us and Bermuda, dude. So if it's a clear night and you look southeast, you might be able to see it. Maybe.
And there we heard that call out for Max Q. Now coming up shortly, we're going to have several events happening in quick succession. First is MECO, or main...
MVAC chill.
Second stage,
there. First
engine
will be
chill.
MECO, or main engine cutoff, where all 9 Merlin engines will shut down in preparation for stage separation, which is where the first stage separates
First
from the
stage is
second stage.
RTLS.
Following this, the Falcon 9 first stage will then perform a flip maneuver concurrently with the MVAC engine on the second stage starting up. Then we'll see the start of the boost back burn on the Falcon 9 first stage, followed by fairing separation. So keep an eye out for all of these events happening in about 30 seconds from now.
Okay, so they indicated MVAC chill, which means they're running propellants into the second stage, priming the second stage engine and getting it to the right operating temperature. If you think like with a car, you got to start it and then it has to get up to operating temperature before you use it, right? The engine does the same thing, but obviously you can't start the rocket engine while it's still attached. Starship does that. So they're priming the engine and getting it ready to go here. Should be getting...
Main engine cutoff.
There's main engine cutoff. Stage separation.
Stage separation confirmed.
Everything looked good. Beautiful shot of the Floridian
ignition.
Peninsula there. That was... So the
Stage
first...
1 boost back startup.
First stage is now turning around and it's going to fire its engine and it's going to fire it away from the second stage. And you could see it. You could see the plume from the second stage. There it is. Oh, that's the best part.
Fairing separation confirmed.
Yes.
And there we heard those events that happened back-to-back, which again were main engine cutoff.
That's the
stage
plume
separation,
interaction between the
stage
first
one
and
flip,
second stages
second
hitting
engine
each
start
other.
one,
That's what that
the
trippy
start
wavy
of the
effect
boost back
is.
burn on the first stage, and fairing
Oh, that's
separation.
so cool. That never gets old.
Now we are currently awaiting the conclusion
the
of
best
the
part,
boost back
dude!
burn, which will properly
Yes!
orient the first stage for re-entry into the atmosphere. And the second stage is firing, which you can monitor in the lower right-hand corner of
All
your
right.
screen.
One boost back shutdown.
Okay, boost
There's
back
that
shutdown. You
confirmation
should see the
of
grid
first
fins start
stage
to deploy
boost
now.
back shutdown. So the next milestone coming up is entry burn on our first stage, scheduled to occur around the
SSRP,
6-minute
Panther.
and 30-second mark. Now that boost back burn is complete, Falcon 9 will perform 2 more burns in order to land.
You got an
The
IR
first
cam
of the
on
2
the
burns
on
is
Falcon
entry
here.
burn to slow itself down before hitting the denser parts of the Earth's atmosphere. You can think of this as similar to pumping the brakes on your car.
And without this burn, we'd only be using the atmospheric drag alone to slow down Falcon 9, which adds extra stresses onto the rocket. A single Merlin 1D engine will relight for this particular entry burn.
Who wrote this copy? This copy sucks. No, I'm just kidding. It's not bad, but I can do better. No. So Falcon 9's going to do its entry burn here. The entry burn is going to slow Falcon 9 down, right? It'll slow it down in preparation for a landing burn. But what it also is doing is it's acting as a heat shield. The rocket exhaust actually acts as a thermal barrier, basically in function becoming the heat shield for the vehicle. And it keeps the reentry heating gases away from Falcon 9, and it envelops it in a cool column of gas. Basically, flying through its own exhaust is actually basically working like a heat shield. It's the best part. I don't know why SpaceX doesn't talk more about this. This is a really, really awesome bit of technology. It was a technology that was pioneered by NASA for Mars entry, descent, and landing, but SpaceX here is using it in the upper atmosphere of Earth, which is kind of similar to Mars. But it was a technology that's developed by NASA called supersonic retropropulsion. Yeah, he said the thing. There's Satellite Beach. There's Cocoa Beach. There's Port Canaveral. Oh, man, here we go.
On Falcon 9's second stage are each optimized to perform in their unique operating environments. An M1D engine generates approximately 190,000
It's solid
pounds of
nitrogen that
thrust
drifted away, Jack.
compared to the MVAC engine, which can generate a little bit over 220,000 pounds. The MVAC nozzle extension, which you've seen in the views this evening, is also significantly taller with a larger diameter compared to
it's
the
the solid
M1D
nitrogen.
engine for
The
optimal
way it
performance
propagates
in a
out of the
vacuum
thruster, it makes a ring, dude. Yeah, the nitrogen thrusters. If you
coming up in about
outgas
30 seconds from now, we should be here.
If you outgas a nitrogen thruster, see those puffing that's going on? It's the thrusters to get the booster kind of centered. If you outgas nitrogen into a vacuum, it'll immediately go through phase change and solidify before it does nothing. Yeah. Yeah, you're outgassing nitrogen really, really quick. The depressurization per the ideal gas law gets gases to solidify. Because, well, once again, ideal gas law. Supersonic retropropulsion is happening now. I'm unmuting it.
And there's confirmation of that stage 1 entry burn
Yeah,
startup.
baby.
This burn will last about 20 seconds.
They switched back to the visible spectrum camera when the SSRP started. Flashbang through the door. That's a long SSRP burn.
Shutdown.
Okay. Okay, there's Florida.
concludes our entry burn.
Coming in
The
hot.
first stage has one more burn left.
There's Port
to prepare for
Canaveral on the
landing.
top of your screen right
As mentioned
there.
earlier, we will be attempting to recover this booster, targeting a landing at Landing Zone 2, which is not far from our launch pad.
Now, the Falcon 9 first stage is equipped with 4 landing legs, which are made of a carbon fiber with aluminum honeycomb mesh, and these are placed symmetrically around the base of the rocket and will deploy just prior to touchdown of the booster.
Looks like the lights are on at Slick 36.
Now, you may notice the number 3 in today's mission name, indicating that this mission is our
Stage 1, FTS has safed.
This mission is our third dedicated rideshare mission
Oh,
to a
she's coming.
mid-inclination orbit. Rideshare
Come on, baby.
significantly increases access to space for small satellite
So
operators
the
around
big
the
light
world.
at the top of your screen is Blue Origin's pad. That's
Stage 1
Slick
landing
36. We got a landing burn.
Now, this is the beginning of Falcon 9's final burn, the landing burn.
Okay, the grid fins doing their job to steer this thing back into position. When the grid fins are no longer aerodynamically effective, Falcon 9 will be running off thrust vector control only. You'll hear the call for landing leg deploy. Grid fins will lock.
Stage 1 landing leg deploy.
Grid fins lock. Landing legs down. 1090 lands at LZ2. Right next
Stage 1 landing confirmed.
to LZ1, where another Falcon
And
9
there we
landed
have
less
it,
than
another
24 hours
successful
ago.
First stage landing.
Did you see
at
the other
Landing
Falcon
Zone
9
2,
there?
Making the third landing for this specific booster and SpaceX's 435th landing of an orbital class rocket.
Damn, that's cool.
Now, as that booster descended, you may have also seen the booster that previously supported our CRS-32 mission last night. And with confirmation of booster landing, we'll be bringing today's webcast to a close.
For those interested in learning more about today's payloads and deployments, head over to our customers' websites for more information. To stay up to date
Should be
with
soon,
all of
all
our
systems.
missions, check out spacex.com/launches for schedules.
We'd also like to
Oh, they
thank all
launched
of our
due
rideshare
south.
customers for entrusting us with their spacecraft today. And as always, a big thank you to the range and the FAA for their ongoing support.
That will do it for us here at SpaceX Hawthorne. Good night, everyone, and thank you for tuning in.
At least get us to Seiko. You guys suck. I wanted to see second stage engine cutoff, man. At least the call for it.
Discovery, go at throttle up.
What? Yeah, Revs. Yeah, jeez. If they ever shouted me out, I would blow a gasket. I'd be like, I'd be like, okay, I'll just go down now. Anyway, all right, guys. That's going to cap off for Space News. That was the Bandwagon 3 mission. I hope you guys enjoyed it. It was pretty good. Pretty good Space News. We covered a lot of ground today. Good stuff. I didn't miss the Atmos thingy. I didn't miss it. I just can't play the damn music in the background.
Knows no
Hear the
bounds.
music? I can't play that. YouTube will get angry. Vastvid. The one from Friday? Tomorrow. You saw that from the Dominican Republic. All right, French. Cool. Did anyone ever find out more about that deer that ran out of the landing zone? No. Yeah, Tessa, we'll wrench on the car tomorrow. We'll finish trying to figure out what's wrong with that motor. Yeah. Good stuff. Yeah, we can wrench tomorrow, dude. I'm in. Anyway, I'll see you guys tomorrow at noontime. We'll wrench on the Coronet. We got more space news, and then, I don't know. Who knows what we'll play for after hours. Should be fun, though. The plug wires did show up. They should be on the fender. They're cool. They're Mopar orange. Oh, yeah, see? There they are. We'll work on it tomorrow. Don't worry. Did you see the car they found on the Yorktown? No, I didn't. Last, please, before you head out. During a launch, how long do mission control people have to stay at their stations? It depends on what your job is, but some people are there. Most people are there for the full duration of the missions. It depends if you're working on launching or mission operations. The mission director is there for the whole thing, Flykin. What are we racing this weekend? Oh, Rudy, I'm not 100% sure. I'll have to talk to my racing guy. But anyway, guys, I hope you enjoyed it. I will see you guys all tomorrow. We're going to wrench on the car and try to get that misfire figured out with that engine. Mechanically, that thing seems pretty dang straight, which is crazy to me. I can't believe how healthy it is. But we're doing, round 3 at Imola, Rudy. That's right, we moved Imola to this week. That's right, Dink. Cool. Anyway, guys, on the Twitch side of things, we got a lot of people in here tonight. Let's see who we can raid. See if we want to give anybody a raid. Who's out and about streaming? On the YouTube side of things, I'll see you guys all tomorrow. Yeah, we should get a wrenching stream in. Etal's playing Blueprints. We haven't raided Italics in forever. WD-40 raided me, and now we're going to go raid Italics. He's playing Blueprints, whatever that is. Anyway. Let's go see what Etal's up to. I'll talk to you guys all tomorrow. Thank you very much for watching. Have a good night.